Good evening, one and all. Hope all are safe and healthy. Myself, Raghavendra Prasad, member, Professional Activities, Educational Activities Committee, and Mentor Student Activities Committee 2021, Execom member, IEEE Bangalore section. I'll be the moderator for today's lecture series on AgriTech. IEEE Bangalore section was established in 1977 and is one of the most vibrant and dynamic IEEE section across the globe. Over the years, the strength of section has grown steadily, and currently the section membership stands more than 8,600. This membership is spread across various sectors and is a nice blend of industry, academia, and research organizations. Section conducts 1,000+ technical activities every year with the help of student branches and society chapters. IEEE Bangalore section won the prestigious NGA Outstanding Large Section Award during 2013 and 2019. R10 Distinguished Large Section Award for the year 2013. This is a brief about our IEEE Bangalore section. Coming to today's topic, so AgriTech. World Bank says agricultural development is one of the most powerful tools to end extreme poverty, boost shared prosperity, and feed a projected 9.7 billion people by 2050. Growth in the agriculture sector is 2 or 4 times more effective in raising incomes among the poorest compared to the other sectors. Agriculture is also crucial to economic growth. In some developing countries, it can account for more than 25% GDP. The agriculture industry has radically transformed over the past 50 years. Advances in machinery have expanded the scale, speed, and productivity of farm equipment, leading to more efficient cultivation of more land. IoT, artificial intelligence, analytics, connected sensors, and other emerging technologies could further increase yields, improve the efficiency of water and other inputs, and build sustainable and resilience across crop cultivation and animal husbandry. McKinsey report says agriculture industry is one of the 7 sectors that, fueled by advanced connectivity, it will contribute to $2 to $3 trillion in additional value to global GDP over the next decade. So it is a very interesting topic to discuss. To address these key points, today we have organized the lecture series AgriTech, shedding light on technologies, research, applications, successful implementations, future scopes in agriculture. So today we have the expert speakers as panel members. Dr. V. ILANGO, Professor and Head, Center of Excellence for Intelligent Human-Computer Interaction, Head Research Center, VTU PG at CMR Institute of Technology, Bangalore. Sir, welcome you for the, I welcome on behalf of IEEE Bangalore section to this AgriTech presentation, sir. Kindly
thank you, sir.
On your camera, sir. Kindly switch
thank
on
you.
your
Thank you.
That. Thank you very much.
Thank
sir.
you for welcoming.
Yes, sir. We have one more speaker, Dr. Prasad KULKARNI, mentor agriculture startup AgriMitra since 2010. Currently working as associate professor in KLS Gokte Institute of Technology, Belagavi. Sir, I welcome on behalf of IEEE Bangalore section, I welcome you to this AgriTech presentation.
Thank you very much for this opportunity.
Yeah. We have one more speaker of today, Professor Prajwal Keti. So he is an assistant professor in the Department of Electrical Engineering, Ramaya University of Applied Sciences. I welcome Professor Prajwal Keti on behalf of IEEE Bangalore section, sir. Please. So
thank you, sir.
The camera
Thank you, sir.
that we can.
Thank you very much, sir.
Also, we have a very good participants comprising of professionals from industries, academia, and also students. I welcome all the participants to this lecture series on AgriTech. So in today's session, it goes like this. We will have presentation from each of the speakers for 25 to 30 minutes. And the last 20 minutes is dedicated for panel discussion and also Q&A sessions. So participants, already we have posted so many questions also. We are very much excited to listen to the speakers as well as to have some questionnaires also at the end of these sessions here. Yes, so participants' questions can be typed in the chat window. We'll take these questions during the Q&A session. So all of you, please unmute yourself and also so that we are going to listen to the lectures from the presenters here. So first, we are going to have Dr. V. ILANGO, Professor and Head Center of Excellence for Intelligent Human-Computer Interaction, Head Research Center PTU PG at CMR Institute of Technology, Bangalore. She has more than 2 decades of working experience in academia, research, and consulting. He is a fellow of Institution of Electronics and Telecommunication Engineers, IETE. He is a senior member of IEEE, member of Institute of Engineering India, that is IEI, and a life member of ISCE. He has organized national level AgriTech 2018, comprised 3 parallel events, Open Innovation Hackathon on Smart Village, Karnataka. He has conference on theme digital transformation of Indian agro ecosystem for equitable rural development and Epitech conclave. He also delivered keynote and plenary speech in various national and international conferences. He was the publication chair for IEEE C2I4 2020 conference. He is also UX and UI consultant. He has published 16 patents as an inventor in the area of information and communication technology. Dr. V. ILANGO is an author of over 90 scholarly research papers. He is guiding 6 PhD research scholars under Visvesvaraya Technological University. Presently, he is working on a research project titled Multi-Agent Based HCI Model for Inclusive Education and Visually and Speech Impaired Emotion Recognition System Personalization. So we are very happy to have you here, sir, so that you can share your thought process and also knowledge related to a part of this AgriTech. So requesting Dr. V. ILANGO in addressing on digital transformation using human-computer interaction and open innovation for agricultural research. So mostly pointing touch upon the ICT for agriculture. Sir, we are eagerly waiting for your session, sir. Kindly you can take over and also you can present, sir.
Thanks for giving me opportunity to address this gathering. I'm very proud to be as a member in IEEE Bangalore section, one of the prestigious section in India and leading and premier section in India. In not only India, in globe countries also. So thanks for giving me opportunity and introduction. Now let me share my content slide. So the slide is visible?
Yes, sir. It's visible and also you are audible. So you kindly you can go ahead, sir.
Okay, I can maximize the slide. It is covering full slide, full view.
Sure, sir. Sure, sir. It's going on. It's
Okay,
good to go.
Right. Warm welcome to all the participants. I hope everybody is safe and secure in present pandemic situation. It's a great forum. We must thank to ICT forum. Because of this kind of invention, we are able to meet in virtual mode to share the knowledge. And also thanks to IEEE and IEEE Bangalore section and Professor Raghavendra and other co-fellow panelists also. So with these introductions, I'll start presentation. Right. So digital transformation using computer interactions and open innovations for agriculture research. This is my topic. So what would be the key takeaway in this last another 30 minutes time? As a participant, as an enthusiastic learner. So human-computer interaction approaches for AgriTech research. So we need to have a lot of innovations presently. Let me tell you why I should do that very shortly. And open innovation management cycle for agriculture. Agriculture field is a very vast field globally, as Professor Raghavendra given introduction. So we need to have a lot of innovations, a lot of ideas should come out to solve the problem, day-to-day problem, societal problem, human-centric problem. Which can increase their economic status also, agroeconomics and Indian economics also, global economics also. So it should have a lot of startup initiatives in our countries. How do we move forward? The youngsters are there, one of the leading hub in Bangalore, Silicon Valley. So it is our responsibility to address these are all the 3 important points. So let me move further. So why we should talk about AgriTech today? So 20th century, there was innovations, technological innovations in the 90s, information communication technology. Information was there, technology was there, there was a gap in communication. Internet came into picture, it was only internet for passing messages. Then it's become web communications. Website came, lot of portal came into picture. Then it moved to e-commerce systems. So late 90s, open economic systems was introduced in globe because of the open economic system. So many of the countries wanted to exchange their business model and businesses from across globe. So people wanted to have new type of competitive environment. So there was a need, much need was there. New technologies was introduced. 2000 later 2000. That e-commerce become effective in developing countries. It's in 2005 late only it was become effective. Earlier 2005 developed countries successful launched. Right. So when it was going on, this development changes, there was a need to address, people were addressing various domain. There was a domain which is most suffered domain and need to address the domain is agricultural sector, because in India, like developing countries, most of the products are livestock product, and people work in the field and produce the product and come to market to survive. Well, purpose they earn money. That was the need was there to advance the quick productions as well as the quick very formalized way of cultivations has to be done. Many did not have that knowledge, literatures, the farmers. They were doing with the classical method. They did not cope up with the modern technology. Advanced countries, they were harvesting advanced way with a very quality product. Developing countries were lagging behind. So it was a need to address. Slowly the system started. Then late 2010, mobile app came into pictures. It was used in many of the people. After that, 2015 later, there was a smartphone system came into pictures. So most of the places in India, probably last village, last mile, last village in country, they may have the mobile phone, probably may not have a smartphone. They were able to get the communication, they were able to learn. So it's a time to address them, to educate them, to do modernist way of farming, modernist way of agricultural cultivations, and to make proper way of selling justification. So this AgriTech will address. Interestingly, Government of India also taking more initiative, effective initiative. Let me address it shortly. And state government also addressing effectively. Right. During this scenario, digitalizations also came. How the digitalizations come to picture, digital transformation. So initially all the document, early 90s, people were convert the document into digital form, analog to digital, preserve it. And later 90s in 2000, they will convert the business process into automation systems. Late 10, they were invented a new business model with the transformations of the digitalization. They were able to reach globe across globe with the information communication technology. So effectively, efficiently, with the optimistic way. So during that time, always we were looking into that user perspective, what user wants to utilize that. So the main aim of the digital transformation was making customer wants to think to making things customer wants. It was the motivations. The digital transformations are performing that using information technology with a new type of innovative business models as well as business drivers. So presently digital transformations play a major role across the globe effectively, efficiently. So digitalization timeline, as I said, that it has been increased from 1990 to 2010 beyond. Now Android systems are become very popular to iOS systems. So the touch screen has come. People used to say smartphone system. Everywhere people say smart, 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 smart. So we need to have smartest way of doing business, doing processes, doing services. That's what required. The latency of the services, latency of the processes, latency of the productions, people wanted to have very optimum, very variable, very minimum. So for that, the digital transformation help for knowledge sharing and effective processing mechanism. That's what present things. So for that, without computer, we are not able to do. Computer include mobile computer, pumped up computers, desktop computer, various level is there. It's a not only computer, human is required. There is a cognitive science, cognitive mechanism, the computer and human interacting together. the computer play like human brains, the neurons like concept, whatever human thinking, like that simulating the human ideas computer effectively, efficiently than a human being to map this so smartest way, the latency things optimistic way. So we need to interact properly with the digitalized mechanism. It is an interdisciplinary domain across various domain, collaboratively work together, do the interactive mechanisms in the business present digitalization, human computer interaction digitalization mechanism era. So in that main content is user, we can say user experiences, everything we need to develop not for ourselves, we need to develop who's our potential user can use it, this product, whatever services or product we are processes. So we need to find out user experiences, what could be their experiences, what they want. According to that, we need to modernize it, we need to develop, we need to construct, and we need to come to the market. So that's way the human computer interactions and user experiences become proactive rather than reactive, strategic rather than limited by its craft. So it is very important to address that. Okay, around this, is it possible enough? No, we need to address what could be the research approaches with respect to agricultural field, how the human computer interaction research approaches can help to develop agriculture related product, how it satisfies the requirement of the farmers or stakeholders, that we need to address that. There are approaches, interesting approaches, and compared to HCI, human computer interaction for AgriTech mechanism. The first and foremost thing, empirical evidence sciences. So first approach is empirical science test. This is a case-based mechanism. It will talk evidence-based mechanism. With evidence, we can go with to develop a product. Before develop a product for a need for the agricultural stakeholder, we need to do a market survey or a field survey, market analysis. So empirical analysis to be done with a witness. We need to prove that this is very much needed. So we have to do empirical science mechanism. This is a methodology. Empirical science is a methodology, qualitative, quantitative, like that. It goes that we need to avoid the biases. We need to move forward with the frictions value, eliminating the frictions value. So this test empirical approaches will help to identify, give the confidence to move further. Empirical evidence alone will not help. We have ethnographic. Ethnographic is study about the people, approaches, people, work cultures, behavior. So we have to visit the field and observe the people, how they work, that we can formulate the mechanisms, ethnographic mechanisms, not only that behavioral thing, how smart people work, how semi-skilled people work, how unskilled people work. So we can make unskilled to semi-skilled to skilled people, and we can pull the talent, and we can make a product effectively, efficiently. This is very much important ethnographic things to understand the requirement of the product development. And another important thing is you have to make a product engineering and design product. So we need to have approaches for everything. We need to have approaches. Informally, if we develop any product, may not have that value from the product in the market, global market. So we have to formulate certain methodology, mechanism, engineering mechanism, systematic way of developing a product. The engineering mechanisms will help us to do that. The three approaches is very important. Quickly, I run through that. So when you have the empirical approach, first observation, what you observe in your field domain. If you took agricultural thing, you want to go for horticulture related product development. So you have to go to horticulture field, you need to observe it, what you observe, keep in your mind from your experiences. You can ask many people, then you formulate that variables of the research cost variable, what is exactly required. They need instrument or they need services, they need to have data analytics, they need to have prediction, or what exactly they need. Formulate the variables. The variable can be characteristic or condition based also. Once formulate, then you make a research questions. After formulate the variable, make a research questions which can help for long lasting the mechanism, process mechanism. So once you're done, go for concrete and testable statement derived. You can make a hypothesis whether it could be feasible or it can be rejected or accepted by the end users, or you can formulate it. Once you're done, you can go for defining operational definitions. Assume that you have done everything, observations, research question, hypothesis, everything is done. Then move forward next to ethnographic approaches. Ethnographic approach is study of human behavior. As I told that entering into the field, talk about cultural factor, observe the cultural factor, and detailed descriptions without appeal to a period theory. So it is a qualitative perspective. So we can have the scriptical way, the scenario we can create based on the scenario. We can go for formulate the problem definitions, then we can solve the problem. That's an interesting mechanism. Then engineering and design approach, and come back to engineering design approach, it's a solve a problem with the solutions that works. So we need to have a lot of concrete and compelling problem with the demonstrator needed. And not only that, we need to have problem solving skill, efficient problem solving skill, and explore how we'll interact the people with the computers in future. And technical challenges always is there in the engineering mechanism. Require novel when come to ICT, information communication technology, maximum based on algorithm based and mechanism based coding and development based it. So require novel non-trivial algorithms or configurations of components is required. We need to find out which would be very feasible and very concrete and quality way of mechanisms, algorithms, and methodology. So as in we have done, one of the interesting things to formulate problems and identify the solutions called design thinking. It's engineering and design approaches. Design thinking is a teamwork actually. We can have multiple brains together, discuss brainstorming work and formulate which is feasible for the user, which kind of user you are going to approach is stakeholders according to their requirement. We can develop the product. So design thinking can be described as a discipline that uses the designer's sensibility and method to match people's need with what is the technically feasible and what a viable business strategy can convert into customer value and market opportunity. Not only that, design thinking can help your team or organization better understand and unmet needs of the people you are creating for customer or client or student, user, etc. And not only that, reduce the risk associated with the launching new ideas, product and services, generate solutions that are revolutionary, not just incremental, learn and iterate the faster. So this is a very vast domain, the design thinking, but anyway, I highlighted few it is must do for product development, engineering based product development. A lot of conglomerate is there, conclave is there in HCI. As I told, that is not alone. We need to perform with the integrated component. All these components together, we can perform, we can make an excellent product. One is UX. UX is nothing but user experiences. So user experience is how user feel to work with the product component that we need to study. We have to develop according to that. It's a major component. Come back to HCI. Any development, if you do mobile app or web designing or product desktop applications, anything you do, this is one of the interesting process is supposed to do that. And user interfaces, so how human and computer interacting. User interfaces, we have mobile user interfaces, conversational user interfaces, graphical user interfaces, web user interfaces. Like that we need to have the frame properly. We can't just like that make a frame with a workspace area. All that we need to study carefully that these interfaces will work. Then important things next, interaction design. The interaction design is nothing but, so we need to have interactive way of hardware components, how digitally it is being worked environmentally feasibly, that we need to study, we need to make modifications accordingly. The next important thing, HCI, human-centered innovation. Anything you do, the innovation should be for human being, by the human being. So human-centered innovations for their human problems to rectify has to be done. It should be studied, that should bring into pictures. As we are talking today, AgriTech, who is there? Human beings are available here. Agriculture, farmers are needed so much solutions for their problem to optimize it. So we have to focus on their field only. Like that, healthcare, many will come to picture. So we need to go for healthcare specialists like that. So next important thing is usability. Usability engineering is a domain. It's a subdomain of the HCI. So we have to study about that, how user is operating our product. So we can identify the probably next versions we can modify and update in the effective way into market condition, according to market condition. The last one, ICT, informations we need and technology we need, and communications to be given efficient, effective communication. There may be a lot of issues, security issue as well as safety issues, all we need to care. So we have to have formulations of interesting mechanisms, visible, invisible mechanism. So information stealing to be prevented. So that information should be processed properly. Technology should help efficiently to take into the front field as well as the back end also. So communication ICT play major role. So we thought this, we cannot do that. These are all the 6 components put together. Human computer interactions satisfy. Each one is play major role. Not only that, computer scientists we require, because computer scientists knows hardware as well as hardware fabrication, hardware inventions, and coding and coding optimizations. All will be taught by them. So we can learn. They will provide the suggestions, solutions for the computer scientists required. And creative design. We need to have creative design. Critical designers as the left brain, right brain should work. That psychologist also sometimes we may need it to help us to understand color makes sense. What color can put for this kind of product designs? All the people will give. Some specialists are available. Then cognitive science. We must have some knowledge about cognitive science, as we discussed that everything is thought process activity. Human beings having that intellectual thought. So how that thought can be formulated as a constructive way, there is a mechanism. And engineering, we need to study about all engineering. Electronics engineer need, electrical engineer need, mechanical engineer, civil engineer, all should work together to formulate their new devices. When rocket should launch, everybody, all type of engineers should be integrated and work together to formulate that. So these are all the major pillars work, the 4 important pillars, along with the ingredients of the 6 ingredients put together, the process of human computer research move forward. So this is an interesting fact. And not only that, present mechanism smartphone have come to pictures, everybody hand we have. So one of the important interfaces system, conversational interfaces are play more. We are lazy to type now. We keep conversation dialogue with the other agents. So conversational user interface is a digital interfaces that allows user to interact with the product based on principles of real life human communication. Put simply, user don't need to look for information in the graphical interfaces. They can just tell the device what to do verbally or writing. As we have Alexa, Siri, so many tools we have, they can use it for effective communications and effective transaction. There are 2 type of conversational user interfaces are there. One is chatbot. Chatbot is based on text basis and predefined code will be written. It is related to particular organizations or particular people. So we have certain restrictions in the chat boxes. It is good and useful, but we cannot have customization and personalization. So there is another interesting things. Intelligent virtual assistants is there. It is advanced versions of chatbots. We can have customization according to people. It can work as an assistant for individuals. So intelligent virtual assistants can personalize according to the requirement. This can have voice as well as text. Multiple components can work together to solve their human requirement. So this is interesting things. As on today, it display various way. Google Assistant is there. So many is there. We can utilize it for our agriculture product development. Even radio system, and now AgriTech software development, the product people are using both chatbots also, IEEE also using for development. Right. So when you go for product development, agriculture product development, what is the first one? First, we need to understand problem study. As we discussed, empirical study, ethnographic and engineering designs, formulate the problems and find the stages and make a scenario. Once you made a scenario, stage 1, stage 2, stage 3, draw the sketch, paper-based sketch as is drawn, as shown in the screen. It will give you more clarity. It could be done in the design thinking level. So at the time of design thinking, teamwork, each team can give their idea, draw the sketch. Finally, it will be consolidated, concrete sketch is ready. Assume that your paper sketch is ready. With the sketch, you go for making wireframe model. That is a low fidelity design, will not have more operational function, but it will give some type of initial prototype. So wireframe model, you can prepare the wireframe model. Once you've done the wireframe model, you can make a component, you can have sub-component as we given the notation, you can give for your designers to understand, the developers to understand. Once you're done, then you move forward to go for high fidelity prototype, which has the meaningful usages maybe icon, color, functionalities can be included, various functionality. This will enhance the performances of the product. So it will be a high fidelity, more attractive, more user friendly. User experiences will come into pictures more happily. They operate the software system. Same device, multiple softwares are able to work, but some of the software very successful, some of the software very complicated in the mobile device, whatever it is. So based on the study, we can go for that. This will help for the farmer. What farmer need? Multilinguistic development can be kept here. They can convert the languages. One software developed in English based that can convert into all the Indian regional languages quickly without time delay. It's possible. The farmer will be very happy. He can use conversation, use interfaces. They need not to type anything, so they can usually communicate wherever to communicate it. That's what's happening now. High fidelity prototype. Once prototype ready, you can move forward to go for formal mechanism. This is one part of the things briefly I said. Next, when come to open innovation, right, we were briefly talk about that. Now we need to go for innovations in the agricultural field. What type of innovations people need? As Professor Raghavendra defined the subdomain of the agricultural things as per the World Bank in the introduction speech. So many subdomain is there. For which group of people you are going to provide the solutions? If you say that dairy farm, dairy sector, what you are going to do? If you say poultry sector, if you go for fertilizer sector, like that, you can finalize that there. What could be the innovative mechanisms could be provided, that we, as we discussed it in the formal way. So look at this picture. Necessity is the mother of invention. This is a beautiful invention, effective invention. I read from the article last 2020 during pandemic April, people invented in northeast side for transportation. Fine, but here you see excellent, seems to be excellent, but it could be viable. It can be commercialized. No, there are various fear factors incorporated with that. How the fueling efficiency come, how the safety measures, security measures, whether it is portable or it can be utilized its regularized mechanism. It is very dangerous. The bike is invented, manufactured by some company, various components are also there. These people have done some kind of appreciation for this innovation. Really, it is appreciable. But how do we take into formal way, commercial way, this product development? Whether this can be drove in the traffic road, how length this is, how big. Even Toyota people, this many people are not able to sit but to 18 lakhs rupees car, 8 people only. But here the 9 people are going for a 70,000 rupees bike. Extraordinary innovation, but which is feasible. But this is appreciable. This idea can take into formal way of marketing or formal way into selling into the businesses. That is very important. So many inventors are having such idea, but they do not have a way to proceed formally. That we need to educate. How do we go formally? That is what important. We need to invent. We need to provide the solution. For that, we need to have open innovation. Open innovation is simple. The term open innovation means a situation where an organization does not rely on their own internal knowledge, sources and resources. Earlier systems was like that. Now present system come forward open innovation only. They will go out of box for innovation, but also use multiple external sources, that's customer feedback, published patent, competitor, external agency, and other common people pull together to their organization, work together collaboratively. So open innovation, simple word you say, invite people from outside. Don't look into only your organization, your places, your idea. So we have open mind to have the collaborative work. From that derive the solution. It's called open innovation. So in the open innovation, there is many advantages is there. The startup company can come, the academia will come into picture. They can put their budget together. They can practice together individual best practices all together, put together. They can create a groundbreaking inspirational technology. In the 20th century, this was not happening. Closed door invention, R&D, some premier institution, efficient professors or scientists will work together. But this trend is broken now in the 21st century, late 21st century, 2010, because of smart technology came into market, mobile phone, internet, everything. People are able to work in remote places. Open systems have come to interest market. It is very good sign, but a lot more work has to be done in a present scenario. So in that open innovation system, how do we move forward innovative mechanism? First, if you decided to do innovation, what are the things we should do? The first step, we need to have empathetic mindset. Empathetic mindset is very important. We have to keep think about farmer, what to be done for the farmer. Let us not think about a global farmer, USA farmer, China farmer, Israel farmer. They are all the leading players in AgriTech in the present scenario. But India is required very much solutions today. So farmer have a smartphone in their hand, but they don't know what for to utilize that. They can provide interesting solutions. We can provide interesting solutions to them. Like that, any part of the farmers, you can think about that. Some area land problem is there, soil fertility problem is there, irrigation problem is there. So like that, who are all having that such facility, land is there, 500 acre, 10 acre, 5 acre, 50 acre, how the solutions can be provided. You keep think about always the farmer. So you get some solutions for the people. You have the compassion about the farmer, and you discuss with the people, so you get an idea. So that is very important thing. Assume that you are having the mindset, you discussed it. Not only that, don't look at the solutions directly. Find the problem first. Identify problem. Create the problem repository, so idea repository, then you go for derive the solutions one by one. So when you create a idea repository, after that, what to do? You build a network. Network is very important. How to build network? You need to collaborate it. Without collaborations, you will not be able to have effective solution, optimum solution in 21st century. So I told 20th century open innovation. I was not there closed innovation. 21st century beginning, it is slowly started. Now it is 100% open innovations are there. Everybody, people talk about innovations like that. So we can have collaborations. We can have memorandum of understanding or mutual collaborations with the peer group or external agency or known people, even informal education who got it, even non-literate people, you can have collaboration. The farmer may not be educated, you can pull them. They have interesting idea. As I shown the figure, they are not educated, seems to be, but they have found innovative bike. So you can have talk to them, you can collaborate. Then you go for formalized the idea. That is very important. Networking, right? Then criticism. Be ready to face criticism. People will demotivate. Whatever idea you are coming with idea, if you go to talk to many people, many demotivate, many discourage. Even our own family member may say this idea doesn't work. You don't have the finance, you can't invest it, you can't get it. So many criticism will come. You must be ready to face the criticism. It may demotivate, it may be depression sometime also. So we must be ready to do that. Good thing, no criticism, maybe it's a luck. If it is there, you have to be positive and proactive also. So after that, resilience is very important. You should come back quickly. Whatever sufferings was there, criticisms happen, you dejected, okay, don't be upset, come back quickly from that mechanism. Resilience mindset is very important. Assume that you overcome that criticisms. You are received. So many innovations are stopped. It is not been moved forward. They take into somebody, I have innovative idea, please educate me. They stop their idea. They don't allow people to grow. It's happening open system. So how you are going to come forward? That's where resilience works about that. Then you can have, once you come up with a strong team member, you can have design thinking, as we discussed a few minutes before. Design thinking will help to provide the most viable product and based on the market opportunity. It will help us to bring the optimistic way of product. Assume that you have done the design thinking mechanisms, you derived effectively solutions for a particular problem. Now you are having solution, but make a prototype. As we discussed the prototype, the low fidelity prototype and high fidelity prototype, complete prototype, make that prototype ready. Now what to do now? You wanted to go direct to market, or you wanted to prevent your idea. So you have IPR. So there is IPR mechanism, intellectual property rights mechanism. You can go through proper organization, or yourself can make a filing of patent or publishing patent or getting grant from patent as a collaboration. As individuals, you can have collaboration. For this, collaboration is very much required. Open innovation system is very much required, because individually going for filing patent, processing, publishing may be very cost effective. May take thousands or 50,000 to 1 lakh also, 4 to 5 lakhs also foreign patents and all. So some organization appreciate your idea. You can have memorandum of understanding, collaboration. They can sponsor for your idea, patent it. Either you can hold the patent as an inventor, or you can sell the patent, or you can give license to people to utilize your idea. It is one. It's not compulsory to go for patent. It is a suggestions because of, between you and your collaborator, how the business process or mechanisms are there. Based on that, you can think about that patenting or copyright. Assume that you have prototype ready with you, then what to do with the prototype? Simply program, I have prototype. No, so you have to go for start something, become an entrepreneur. So you can become an entrepreneur. You can do the startup as agripreneur. People used to say in agricultural anything you start agripreneur. Presently, digital entrepreneurs are more in India coming up superbly, particularly agripreneur number one. I am very proud to say many state people, many country also are attending today. So Bangalore is the number one for agripreneur. Many digital startups are there in Bangalore. Agriculture related startup around in country the 20 to 30%. I hope so. That I read the NASCOM report. So many states are coming forward. Now they woke up, they started new innovations in agriculture industry. They are coming forward, but Bangalore leading the advantages Silicon Valley. But as on today, so many agri-farm digital entrepreneurs, they are startup, they are actively doing, effectively doing, efficient doing. They are leading others also to come up to the industry, agricultural field to provide the solutions. So once you become a startup entrepreneur, what to do? Advertise your product, your services, your processes, then market properly to utilize this in and brand your product. It's all related to each other's, automatically it will come. So this is one interesting thing. But now present requirement, there are so many things required, particularly India is a diversification, unity in diversifications like that. So we have a lot of scope, plenty of scopes is there. Many of the foreign people would like to invest in India for a startup, new startup. Many people are there. So social entrepreneurs is one of the important things. I would like to suggest that in Northeast, if you go, there are more craft oriented handicraft items are being the designing and selling. They are struggling to bring into market quickly and export it also. It's happening successfully with the government support, but it can be digitally can help it. Amazon was doing that. Why Amazon? Why can't individual people? So like that, you can have social entrepreneur, which is related to social problem, social projects can bring into a solutions product to the market. So regional wise, there are various things we can customize it. This is one interesting fact. So these are all the open management system. If you do organizational level, there are a lot of policies make organization level. First, you should have trust among the people. So open innovation system, we should have trust each other. Should trust by people join together. We should have trust 5 years, 3 years, 10 years. We should work together. Then we should have ambidextrous thinking. Double left brain, right brain should work. Creative, critical, knowledge sharing attitude is very important. We should have an open mind. We can share knowledge, teach, learn like that mechanism. And diversity management is required. Proper strategic planning, adequate partner, strong relationship, and collaborative culture. We have to create ecosystem in organization or within the group or the community. That is very important. That's a challenging, but now people getting knowledge updation through smart devices. And clearly intellectual property policies to be defined, and infrastructure should be made in locations, organizational structure and governance, and funding, self-funding, or we can have crowdfunding or various funding mechanisms, and stakeholder support and process of innovation management and key performance indicator for innovation management. These are all the ingredients we need to formulate. If it is organization level or group level, we can move forward. Government of India is already taken initiative for startup. It is a common way they took startup. Agricultural startup also there here. Startup India, we can go into their website. A lot of scheme they are announcing and approaches, and Atal Innovation Mission, a new generation innovation and entrepreneurship development center, and Make in India, and Biotechnology Industry Research Assistance Council, and SAFAC Venture Capital Assistance also there. But there are many more. These are the few important things I have brought it that. So we have seen first part HCA research for agriculture, then open innovation. Now we are coming to AgriTech. What are the various players, key players are there? What problems exist? What problem we need to address that? We are going to discuss another 10 minutes time. So AgriTech. So agri-tech or agriculture technology is a term referring to use of technological innovation in agriculture to increase field is yield, efficiency, and profitability. This includes using technology to achieve faster planting, modified crop that grows well in different different environment, and harvesting. As we know today in the world, one side urbanization is going on, one side industrialization going on, so people are forgetting agriculture in the city. So urban farming is very important. So vertical farming is very much support it is giving to solve some of the product development in agriculture. Vertical farming is a key important domain. We need to address it. We find the innovations in that. And urban farming also, that there are other more smart farming. People used to say we need to address that. This technology will help us. The AgriTech address for that using ICT communication. Right. The evaluation of agricultural technology, as we told, as on today. So after 1950 green revolutions, now we are in the post green revolution. We are in the ICT. IoT play a major role in that for agricultural mechanism providing solutions, and not only IoT. So people need to have smart solutions with various activity, blockchain technology, artificial intelligence all play major role as on today. So we can make a lot of explorations from that. So why India needs agri-tech present scenario? As I told, many smart cities are coming. Government has announced a smart city. Parallelly, smart villages should be announced also. So everything making infrastructure, buildings as well as other facilities, but agricultural. So we need to have vertical farming or urban farming that may solve some of the problem. Urban people may not need to depend 100% on villages. They can cultivate, they can take their own item there itself, they can export it successfully like that only. Not only that, employee rationalization. In India, as Professor said, 43% of India workforce is agriculture, contributing 16% GDP. Market linkage. Farmers are unable to get their price due to limited sales channel. And financial services. Lack of adequate data prevent the adoptions of financial services such as credit and insurance. Supply chain. Post-harvest loss in the India amount of 13 billion US dollar. And digital infrastructure. Data and digital records for transactions limited across the agricultural value chain. And land degradation. Farmers are not educated enough to use fertilizer efficiently, leading to worsening soil quality. So we can address all these things to solve. These are all the problem definitions we can address to say a product. So agri-tech is being considered as one of the disruptive technology. How it's going to enhance the society or agriculture sector. So agri-tech can lead to increase the productivity in capital and labor. So agricultural incremental disruption. Agri-tech can lead to value additions and diversifications of function. Agri-tech can lead to increase in regional trade and cohesion. Agri-tech can lead to increase in skill acquisitions and formalization of job. It is one of the important things. It is give wealth distribution as well as job creations also happening. There is a myth about agri-tech means technology come, agricultural field will be distracted. No, it is not like that. Who knows, who was aware of that vertical farming will come, urban farming will come. It is a new innovations, present generations it came. It is going to help many people, employability is creating. Agri-tech can increase opportunity for youth and women entrepreneurs. Not only women, many people. Agri-tech can be means to improve redistributions of value. So there are full range of disruption and part range of disruptions is there. This is the AgriTech is going to support. And AgriTech innovation mapping, there are very interesting things. IoT play. I will quickly finish it up. Other speakers also waiting for me. So Internet of Thinking, we can use more sensors to identify moisture content as well as irrigation system or security system. We can use it. And smart farming, we can use smart farming system. In various we can optimize it. We need not to waste resources, whatever natural resources. We can preserve it for the next generations or maybe subsequent cultivations. Also, we can identify, we can predict, we can use it. We can have the precision farming technology can be used effectively, efficiently to do cultivations. What could be the quantifications for particular manures or particular product to be done. Then drone and satellite can be used for security system, assessing for the agricultural field insurance or any disasters comes or safety security. We can use it any way. We can use it. Other experts will detailedly explain that. And big data and AI can help to have predictions and analysis mechanism. Robotic and automations also, we can use it. And vertical farming, as I told, that it is very much needed, and biotech is very much required. So as we have human being DNA like that in agriculture, also seed and various things, DNA can be analyzed it, a hybrid way we can produce it. The corn today, earlier it was yellow, green color, now different type of color corns are being cultivated. It is a new type of inventions happening in India. So that's where the biotech is helping. These are all the very important area innovations helps that. Even drone satellite, you need to find innovative way to utilize it in the agriculture field. This is a very important ingredient. You can use AgriTech as a pillar for the AgriTech. Then AgriTech startup, various startup, as I said that in India, so crop, the big data based cropping, and these are all the startup holder very dynamically served the nation during pandemic crisis time, COVID is crisis time for all the field. So cropping, AgroConnect, and some more also sir, big data they were using, and market link model, AgroStar, Unity, as well as Gramophone and Big Hat, many are using for market link, helping farmer to keep abreast with the market price and scenario. So, and the next important thing, farm as a service, providing for agriculture equipment for renting. So people get the interesting support from that. Farm as a service, like we have software as a service, SaaS we have, FAST we have, providing affordable technology solutions for efficient farming. Not only that, IoT enabled things, various way monitoring, remote tracking system, Bitmantis and Nopsol, like that. So many companies are there. They are all the very key player during pandemic. They played it. Government supported. They're successfully leading. Most of them are there in Bangalore based it, and few of them in other part of the countries. Right. This is a very interesting thing. Not only that, big corporates also enter in the market. They are supporting various way. For agricultural based, agri-tech based innovation. They are sponsoring also. They are a good idea. They're sponsoring like Cognizant, Accenture, ITC, Infosys, Mahindra, Tech Mahindra, Tata, TCS. We approach proper channel. They encourage, they provide, they will be a partners. Also venture capital systems as well as various supporting mechanism. They too have their independent tool to support agricultural thing. In addition to that, new idea, new groups, they are encouraging, they are supporting, they are having, for example, what I understand recently on interview, Cognizant CEO Lakshmi Narayan was saying that Indian Institute of Science Bangalore, they have set up 2 incubator center for COVID virus innovations, are providing solutions. They are sponsoring for only 3 people are there in that lab, each people. That's what he was giving the interview. He's invested, the company investing for their people to do very effective innovation. These are all the corporate have tie-up with India premier institutions like IIT, IIM. They are helping, and other institutions, second tier, third tier people also, institutions also, they are providing support. You go with the innovative idea, the idea to be validated, verified with the prototype. They will really help us to launch in the market. Not only that, and key areas for startup in Indian agriculture sector. So one of supply chain, Indian supply chain, we need to address e-distributor listing problem. Platform and marketplace, and infrastructures, a growing system and component, aquaponic and hydroponic and drip irrigation, finance, fintech. Fintech is very much important to support to farmers, financial support, how to get that loan and disbursement of the prices, price fixing, pricing options like that. The fintech technology will help it, revenue sharing and lending, all those things. So though we have small things is there, ATMs and like that only, but exclusively finance, we need to provide very interesting solutions for mobile based solution. Then farm data and analytics integrated platform, remote sensing software platform, farm mapping, farm management solution, field operations in this area. These are all limited, lot more is there. It's a core area to be addressed to find the innovations and bring up the startup. And information platform, information dissemination, data analytics, or various things we need to have. Some today huge demands are there, right? So this is one interesting thing. And government initiatives, governments also support various government of India, ASPER, a new gen IDC and SAFC mechanism, and ST, NST, MIS, and service there, and JAIM is there. These are all the government subsidiary agencies. They are providing some incentives as well as some loan and subsidiary. So we can approach them. Any persons have got interesting idea, so they can approach with the proper prototype and proof of concept. They encourage to do that. And not only that, and a lot of incubators and accelerators also functioning in India. One of the important thing, IICE, the Center for Innovation and Incubation Entrepreneurship, they are encouraging the new idea. They are motivating in AgriTech innovation. And NIRM is there, National Academy of Agricultural Research Management. They are also supporting various innovators presently, and International Crop Research Institute for the semi-arid tropics, that is also helping, and Indigram Lab Foundations, they are supporting like anything for the innovators of agriculture. So this is another interesting thing. And key agri-tech investor, there are people willing to invest if we approach other than, as I told, big corporate. These are all the people with list is there. They are also helping the proper innovation. But everything should have proper collaborations, formal way of legal way of collaborations. It helps to move forward. Right. This is an interesting thing. And Indian agriculture system has some challenges also. Every new dimension, new innovation challenges always exist. So low landing size and return for investors and talent retention and long gestation period and technology affordability, skill affordability, acquisition of agri-tech companies. So in India, it's very difficult to have a big company cannot take over the small company. It is always negatively also the positive things also there. These are all the important challenges. There are certain hidden challenges also exist. We need to address that. So this can be taken thoroughly and studied thoroughly, then go to market and find the solution, either process oriented solution or product oriented solutions. We can or design oriented solutions we can provide. The three way we can have it. So other than that, Government of India organizing every year agriculture grand challenge. Through that, they are making students or young aspirants to participate in this event. They are providing lakhs of rupees as a competitor, as a winner, first prize, second prize for small solutions. They will link with various corporate. The corporate will take your idea, they sponsor for startup. So this is also happening every year. They are organizing. 2 days ago it is happening. The 2020-21 completed in July 15th. It's completed. So every year June, July they organize it. It was effective mechanism. Students are there. They can approach us, or any corporate people willing to do that. They can also have more with the institutions. They can take to industries. That's what happening. Then precision farming, the next way of Indian agriculture. The precision farming, deep tech resolution is a revolution, is the reinventing Indian agriculture. So this is going to play a major role using empowering farmers with technology like GPSs, sensors, soil sampling and telematics and robotic, etc. This play major role. So in presently. So at last, so AgriTech startup can change the outlook of agriculture by constant innovation. Therefore, it is the right time to boost their confidence. We need to give the confidence to the farmer, stakeholder, and the people who come forward to provide a solution. So we'll motivate all of the stakeholder, will bring the solutions, will change that agriculture sector and move forward, will increase that agriculture income, national development. So with this, I will conclude my presentation. So these are all the important resources we can refer. I would like to suggest that first one, if people are taking notes, manage.government.in. It's an interesting website. You can go. A lot of startup, 100 startups are today effectively done. It is in Hyderabad. This is a government, central government agencies. You can get that detailed input and startup talkie. It is beautiful. Only agriculture startup Asan today what is exist with the descriptions, process flow, work model, everything is exist in that link. So another thing, AG revolutions in solutions. This is also a beautiful website. So you can refer it. Rest of the thing, research papers and other things, you can read it as your own. So this is the important resources. So with this I'll conclude. So any questions I can take now, or I can take it at the last after the presentation.
Yes, sir.
Thank you very much.
Yes, sir. It was a very great presentation, sir. And overall, you have covered all the technologies and also related to design thinking, and so many inputs you have given. It's a very nice overview of the AgriTech. So we can take up these questions in the later stages. Very nice of you, sir. It's a great. And also, I think 30 minutes was not sufficient, because we may have another one-day session also related to so many technologies as well as the opportunities. Really, it's a very, very interesting to hear from you, sir. Please be there so that we
Yes,
can
sir.
ask questions in the later stage.
Thanks. Thank you. Thank you for good opportunity. I am waiting. I will watch other experts
Yes,
also.
sir. Yes, sir. Yes,
Thank you. Thank you.
Yeah. Very nice. And the second, we have got Dr. Prasad Kulkarni. He is a mentor for agriculture startup AgriMitra since 2010. Currently, he is working as an associate professor in KLS Gokte Institute of Technology, Belagavi. He is an experienced professor with a demonstrated history of working in the education management industry, skilled in research, market research, management, data analysis, and strategic planning. Strong educational professional, graduated from Jawahar Navodaya Vidyalaya, Kukanur. So his research interests are data science, social media, online retail, digital marketing, neuro marketing, marketing 4.0, and industry 5.0. He has got so many certifications. Only some of them I'm mentioning. English for doing business in Asia, and Python from Datacom, SQL from Datacom, data analysis and digital marketing. Sir, we are very happy to have you here as a presenter, and also we want to have so many questions also to you guys related to what is the impact related to agriculture 4.0 and also agriculture 5.0. So I request sir to present related to the agriculture 4.0 and 5.0. What is the impact of blockchain in agriculture? Sir, kindly you can proceed, sir.
So thank you very much for the brief introduction. I also thank the delegates and the participants here for having a wonderful time. I thank ILANGO sir for giving me the brief introduction of the topic here. Hope my screen is visible to everyone.
Yes, sir, it's visible and you are clearly audible.
Yes, sir. Thank you. In today's agenda, I'll be covering about what is agriculture 4.0 and the 5.0, introduction to blockchain technology, and the traditional mode of agriculture supply chain and how the blockchain is transforming. A case study from the Infosys, and also how Andhra government use the blockchain for the land records, and our experience in AgriMitra and modern Polix, which works on hydroponics and aquaponics. AgriMitra works on the blockchain for agriculture supply chain in Belgaum district. So I'll be sharing that. So starting with the evolution of agriculture 5.0. Agriculture 1.0 was a traditional method of agriculture where human beings are involved. People were doing the flowing, people were doing the sowing, labeling the feed. Then in agriculture 2.0, the mechanization started. People started using tractors, flowing machines. Then we come to the agriculture 3.0 from the 2000 till today, where we started using the remote sensors. In our startup AgriMitra, we have taken the satellite images to find out why the crop in the one side of the field is having a lesser output compared to other side of the field. Then we went for the soil image analysis, we went for the nutrient analysis, then we found that certain deficiencies in the nutrients, then the climate weather information was not attached. Then we also worked on the hardware side of the components, and it is having the sensors. Okay. Right.
Excuse me, sir. Hello, sir.
Yes, sir.
Your voice is very feeble. You can take the mic nearer.
Yes, sir. I'll do that one, sir.
Please.
Yes. Hope it's now audible, sir.
Yeah. Now it's audible, sir, properly.
Yes. Now, the agriculture 3.0, we started using the satellite images to find out why the crop in the one side of the field is having lesser compared to other side. That's where we started working on the images and how to go for the weeds removals using the weedicides, and we started with a drop by drop, not by liter by liter. Water irrigation is now on a drop by drop, not by liter by liter. This is where agriculture 3.0 we are implementing in the field in Belgaum district here now, using the company called AgriMitra and the modern Polix. Agriculture 4.0, sir has already briefly introduced. Let me take into the artificial intelligence. We have a handheld devices that is connected to the sensors. The sensors, when the weed is removed in the field, gives us the data in the server, and we now tell the sensor, okay, this is not the way of weeding by the man. We give the instruction to the man. The bot gives the instruction, not only we. So the bots are used in the agriculture today. Many people started doubting our ability in the beginning because farmers are illiterate from the rural area. Will they use it? I start giving the one example to them. Okay, today in a rural area, people use the geophone and they hardly know about the QWERT, they hardly know about the touchpad, but they use the Google Assistant and enable the YouTube video and watch the video. Are they not using the artificial intelligence? Yes, that is where our motivation has increased. As the common man now taking the picture and uploading on the crop information for the crop insurance. So the myth is agriculture and rural people do not understand the technology. Today, rural customers are more using the data than the urban customer. That's the data. And they are using more AI products than the urban people. So that is where artificial intelligence is going to change the agriculture. There are a lot of questions I have seen on the IoT side. We have a device in the AgriMitra wherein we connect the devices with the sensors, cameras, and these are connected to the plug-in devices. I'll be showing the device later. So now we can take the images of the crop, image of the weed, image of the soil directly from the farmer, and we can operate it. I'm staying 200 kilometers away from my native place. I am having the IP camera in my field. I enable my starter from my mobile phone. I just on a click, I'll start my starter. And my starter is also having the sensor. The moment the water level increase in a particular field, space, it automatically starts. So agriculture is using IoT. I'm telling you, the common man who do not have a technical knowledge also using mobile phone-based data system today. That is the power of technology is going to the common man, and it is not an exaggerating. It is what is happening. And the precision farming, as I was telling about today, when we went to the sugarcane, because Belgaum district we have 13 sugar factories. And when earlier education was put the water, forget about the crop. Whenever required, put some urea or DAP or NPK fertilizers there. Then we are telling them so much of water is not required. And we are also telling that which part is irrigated, which part is not irrigated, sitting in front of the computer, taking the images from the farmer. So now farmer is now utilizing the water better. We also tell that weedicide or pesticide did not to put for all the sugarcane or paddy. Select the crop. Now we are taking the particular plant in the sugarcane field or in the paddy field. We are making that paddy or sugarcane to be put urea to be used, fertilizer to be used. So farmers are saving huge money because of this precision farming. This is one example of the precision farming. And another one is information communication technology. One more myth is rural people cannot understand the weather market information. This myth was broken by the ITC when they started each open in the Dawn district of Madhya Pradesh. Today, a person from the ITC called Sanchala, there is a Gram Panchayat person called Sayoji. They are giving the market and weather information. For your surprise, farmers in the Dawn district of the Madhya Pradesh. I'm not telling this. This is a study done by the Michigan University. Video is available on the YouTube. Farmers get up at 4 o'clock and come to this ITC's e-Chopal and see what is the commodity rate in Chicago Board of Trade, CBT. So imagine now, how many of us know commodity trading here? How many of us are really into share trading? A illiterate farmer in the Dawn district see the CBT terminal and decides the soya price in his mandi. That is the power of ICT that is there. But entire my presentation is now concentrating on the blockchain. So let us see blockchain. After this, what is agriculture 5.0? Agriculture 5.0, as I was telling you about, we need to work with the robots in the future. And the future, the farmers will be using robots along the way because As a son of the farmer, I also have the field. We know how difficult to get the laborers in the agriculture field today. Even during the lockdown, the many youth in the India thinking that agriculture job is not suitable for them. So the robots will replace such people, and man will work with another robot, what we call as cobots. And these cobots will lead to the more number of human-machine interfaces. That means man has to converse with the robots, man has to work with the robots. So that is how we are reducing the cost in the agriculture. So that's agriculture 5.0. Coming to my topic, what is a blockchain? How Infosys defines the blockchain? A blockchain is a growing list of records called blocks, so that are linked together using cryptography. Seems to be very, very technical for the non-technical person. Let me simplify. Say Indian farmer who grows chili in his field takes to the purchasing from the dalal. So he goes to the mandi and he sells the product. Then the mandi person takes the logistics, go to the cold storage where these are stored. From there, the company like MDH comes and purchases the chili powder, and from the MDH it comes to the DMart, a retailer, who ultimately sells the chili powder to the Commonwealth. So this is a supply chain I'm telling about. Now, what are the records that is happening? Okay, I'll take my own example of the field, what I'm doing. I'm a farmer in the Kustagi Tehsil of Koppal district. I sell tur produced to the Dalal side at a Koppal for 22 rupees kg. Please see, this is a fate of Indian farmer. When you buy the tur outside, it is 105 to 110 rupees per kg, whereas we farmers are selling it at 22 rupees per kg. That means my first record is here. So I'm coming to the blockchain, the record number 1. I'm the farmer selling my tur to the Dalal third in Koppal, 22 rupees kg. So there's a one record in the supply chain. So that is like a ledger record. So I'll explain everything, but slowly I'll take you to the blockchains. Now this Dalal who purchased the tur from me gives the money to me from the State Bank of India. So now there is a second transaction between the SBI and me and Dalal side. So that is a record number 2. Why I'm telling you? Because if I start explaining the technicalities of the blockchain, so few people may not understand. Therefore, let me explain the record transactions here. The Dalal said hire VRL services, logistics, to send the tur from Koppal to civil processing unit in Kalburgi. Now look at the price. He sells this is for 35 rupees per kg. And the Dalal pays for VRL logistics services. Now there is a third transaction or a record that is happening. This is the block I'm talking about. So there was a first block, second block, third block. Now, processing cell, the process to Tata's, which buys the dal for the packaging unit at a 60 rupees per kg. He uses Safe Express for logistics. Look at the number of intermediaries involved in this supply chain. And the Tata pays the civil via HDFC. So one more financial institution has come into this blockchain. Now, Tata sends the goods to DMart Bangalore for 80 rupees per kg via Gati. That means the Tatas are entering one more record, and the DMart is getting one more record. Gati is also paid in between, so there is a records are maintained. These are the blocks I'm talking about. Now Gati gets the payment from Tatas via HDFC. So there is a financial record is there, or a block is created. Now DMart pays the Tata to the via taxes. So now there's a one more record or the block is created. So this is the traditional summary that we're having. Now what happens in the blockchain? All these people, that is me, Dalal in the corporate, civil processing unit, Tata's, VRL, DMart and SBI, all of us will come together and will say we'll take a one platform, the Infosys blockchain solution, and we have a single record maintained. Many doubt that is it possible farmers will be enabled. Small farmers it is difficult. Yes, as a mentor for an agricultural startup, I feel this. But a bigger farmers who are having 50 acres, 100 acres, yes, the yield is more, so they can participate in this. Then is it viable? If there is a change in the Dalal or sibling Tatas. I'll just take a simple example where women come together for the kitty party. They share certain amount and they enjoy the day and they go back. But with a financial transaction, do they maintain anything? No. Next time they come back, once again sit in the kitty party, then once again the amount is exchanged. Is there intent? No. So the first fundamental thing for the blockchain is required is a trust. The former A, that means Dalal, Civilink, Tatas, BRA, DMart, SBI, HDFC, Access, and the Infosys should have a trust in the blockchain. Then, is it necessary to reveal all my transactions? No. There are two types of the blockchains. One is called as private blockchains and the public blockchain. We can limit what we are sharing with other parties. And the public blockchain, and anyone can enter into the blockchain. Private blockchains are very, very secured. Okay, so let me explain the entire technicalities of the blockchain. When the person enters the data, so I'm talking about the bitcoins here, the from to amount is entered here. So suddenly there is a hash is created. What is a hash? Like a fingerprint that you are having, a code is generated. You can see the code there. Now, assume that the blue one is me, yellow one is Dalal, and the red one is a processor. Now, if I create a hash, initially there is no hash. Okay, therefore the previous code was 00. You can see on the slide. But when the Dalal wants to enter the record, he has to mention my hash. Now my hash is created automatically, then he will create his hash. And similarly, the manufacturer also create the hash. Now, okay, I'll come to the technical here. Whenever there is a hash is created, it takes a time. So therefore, if the proof of work is more secured. Now, assume that in a P2P network, we have 6 parties. Okay, I'm showing the 6 parties here, peer-to-peer. The moment any transaction, say I am entering the data, I'm selling 20 quintal of to Dalal Y. I'm entering this data on my blockchain. This information will go to all the people, that is to the Dalal, to the manufacturer, sorry, processor Civilink, it goes to the Tatas, it also comes to DMart. So everyone in the supply chain say, yes, we confirm this transaction. Once this transaction is confirmed, that means it is very difficult to change. Why it is very difficult to change? You look at each of the previous hash is linked to the next hash. So if anyone want to tamper with this, he has to get the permission of the all 6 people. That is the power of this blockchain. That means it becomes tamper-proof. Even the hacker want to come and attack my computer, there are other 5 computers which will not allow to change the transaction. Therefore, these are cryptographically very, very secure. Blockchain. Why the blockchain is secure? Because of this. So it is now connected and okay, protected. So once the data entered in the blockchain, it is difficult to change. I'm not saying it is impossible, but all the parties in the blockchain has to agree. So what are the benefits that we have seen on the ground when we started the pilot project with the Agri-Mitra? We can now start tracing that which vegetable is grown where and how much is the demand in the market, what is the weather situation. Should I tell the farmer to put it in the cold storage before bringing to the market? So that tracing is possible now. And because myself, and the Civilink processing, or the Tatas, or the DMart, everyone knows about how much is the produce coming from the agriculture, how much I can prepare, what can be the price. There is a transparency in the entire supply chain. That is the advantage of the blockchain. Then there is, well, the moment I entered, I have 20 quintals of tour available with me. That stop transaction, everyone will come to know. The Tatas can plan for other stores, Tatas can plan advertisement, and also similarly, the demand can plan for the promotion or storing. So instant transactions will help everyone to get the better price today. And because of that, I as a farmer, I will know, okay, there is so much of inventory left at the Tatas and the demand. Should I grow the crop this time or not? Or should I reduce the number of hectares which I'm growing in the tour? So that is where I'm streamlining the inventory. So therefore, AgriTech and IoTs are used, as sir was mentioning. I'll not get into the details of that. Now I'm coming to the case study of Infosys blockchain implementation. This is a live example I'm taking from the Infosys. Raj Kishore, he grows the potato from the country. Okay, a vendor in Mohan who operates from Hyderabad and Infosys, he contacts the Raj Kishore and said that I want to get the information about the potato. Then there is one more Mr. Charles Baker who sits in Europe, Netherlands in particular, and asks for the information. Earlier in transaction, if you look at the international documentation, we require country of origin, we require insurances, we require invoices, we want the certificates. It was, and Charles, for example, in this example, Charles never had an opinion about Raj or Mohan. So he was struggling to, there was a lot of time. So they were asking for the proof, a sample, all that was taking time. Now, what happened in this? Everyone has come into the blockchain today. Now, the contract between the Raj and Mohan, whatever that is happening, Charles can see it. The contract between the Charles and the Mohan also seen by all the parties in that. Now, the moment the insurance is provided, that is uploaded in the blockchain, a certificate is created. So there's no time limit. So there is inspection to be done for the vegetables and fruits that is uploaded now. A delivery receipt has to be given by the Mohan to Raj. That is already done here in this blockchain. So blockchain is now speaking the streamlines. So if I have to explain the entire Infosys model, the contract between the Raj and Mohan starts here. The contract between Mohan and Charles here. The insurance required for the international transaction happens here. Then, because of the different countries having the inspection certificates, they are uploaded by the blockchain here. So everyone can see that. That means my supply chain is not limited to India today. I can work with any party in the global supply chain. And delivery receipt is there, received. Immediately the bank transaction from the Mohan to Raj is happening. That is also shown by the Charles. Now, when this happens, a mango pulp inspection certification is also uploaded. Now, simple request is automatically generated. Then the bill of lading is taken from the bank transactions and the Charles and Mohan. So the entire network that we're having is secure. That means Charles sitting in Europe can see what Raj and Mohan is doing today in the Uttar Pradesh using the Infosys blockchain solutions. That is the connectivity that we're having. Now, I'm coming to another case study of how land records are implemented. Now, that was a private blockchain. I'm talking about a public blockchain here. Okay, we call it as ROR, Utara, Pani, land record, RTCs, all that. So it's the same thing. So earlier in a village of Talati, our village accountant is to write this and give to the farmers. There are a lot of manipulations and litigations is to happen. Then came the digitalization, dematerialization, demanding of the land records. In Karnataka, we have a Bhumi project. So the parties or RTCs or Satbar Utaras are dematerialized. Still, some problems were because the unique ID is not created. And whenever there is a loan taken by the farmer, it was used to take a lot of time. Say, for example, farmer takes a loan from Primary and Land Agriculture Development Bank, PLD Bank. It used to take 30 to 40 days to update on the RTC. And by the time the farmer got another loan from the public sector takings. So there was not much cooperation in the registration department, revenue department, local bodies, survey department, agriculture department, and the banks and financial institutions. That is the time Andhra government decided that we will bring all this under the one blockchain. That means all the parties has to agree. The moment SBI gives the crop loan to the farmer, automatically it is updated in the Prani so that the credit scores also can be taken, and other banks also become cautious because already there is a loan on the farmer's head. Now, how the certificate looks like? This is one of the blockchain certificate by the Andhra Pradesh government. And now you can see here, this is a certificate generated after the transaction, which is tamper-proof because revenue department, registration department, financial institutions, local bodies, survey department, everyone has to agree. Now, what can you apply it for plot? Yes. You can apply it for a plot level info today. Even the CTS number you are changing in the Andhra Pradesh, it is now entered in the blockchain and the certificate is generated. Can we give it for the layout of the colony? That is possible. So the blockchain is implemented even at the minor levels. We are coming to the my own experiences. That is a mentoring that we are doing for AgriMitra. So how we are implementing, this is an implementation stages. It is now funded by Bosch, DNA. It is also part of the Karnataka New Age Incubation Network. It is an incubation in the KLS GIT Belgaum. Okay, this is Agriculture 4.0 and 5.0 we are doing here. This is entire blockchain that we are now maintaining. This is the architecture. We have a different categories, different types of the people, different market, crop informations, then the weather informations, the government schemes, all that is coming to the picture. So, okay, rather than showing that, what exactly we collect the information on the pin code basis. So, for example, 59008 is from the Belgaum. We ask the farmers to enter their land size and the pin code. So immediately the pop-up comes as you see in the screen, either in mobile or the tablet. The crop information pops up, like which crop is suitable, which crop you can grow, what is the weather situation, all this. Now, okay, we are now one step going ahead. We call it as predictive analytics here. That means each crop is having the life cycle. Say we have a green gram, 1 month green gram that is grown in this area. We can now tell with the APIs of the green gram at the exact 12th day if the soil is not going to pest will come. This will give the farmers on the 9th day so that he can put the pesticide or can make it more cleaner so that the pest will not be attracted. So we are now making crop planning to the minute levels. So farmers are interested. It is not that farmers have started showing a lot of interest here. So we are now making it in regional content also. Marathi and Kannada is dominant here. So we are making this app in this. You can see our app information in the regional content also. So now we are providing the crop information in the real time. Say weather is changing today, that information is given to the farmers immediately on their mobile phone as a push notification to them in the regional content. We also provide them the market information. What is the price of the green gram today? What is the price of the potato today? And what is the quantity that is available in the market in Belgaum today? So that the farmer should think that should I bring it tomorrow or not, looking at the demand and supply. So this information, we are linking it here. We further goes and we also tells about what inputs to find the suppliers and when, because many times the farmers do not get the inputs on time. So we now connect the suppliers and the pesticide, weedicide, fungicides. These people are connected to the farmers using the AgriMitra blockchain technology. Slowly we are making it bigger and bigger, but this is in the implementation stage. They have a user navigation facility. The moment he can change the crop, we are also now telling that how many seeds you can put it in a particular plot. So now, in local language, we got this Angla. So I don't know how many people are here from the farmers farming background. Angla means that it becomes wider between the seed and seed, length is increased. Agro means it is very, very close. The crop will come down. So therefore, we take the information as it's shown in this picture. The moment they enter the plot information, actually you can keep 20 seeds in this particular plot area, and this is the distance required. We have seen the yield has increased by 20 to 30% by proper plot management. So that is what we are providing. People can now navigate using on the mobile phones, on the laptop also. This is helping the farmers to save their inputs. We are now also having registered users, network of registered users, manufacturers, retailers, and stakeholders who are now agreeing for the P2P. That means that the companies are coming forward and now are interested showing directly buying from the farmers. What we call as a contract farming and corporate farming. Both are happening in Belgaum district. And they are now into the AgriMitra platforms. We are not into the mass customization, mass scaling yet. But we are now in the beta version. We are working on that. Then, I will come to some of these things. Now we can see. Sir.
Hello.
Yeah.
Yes, sir.
1 or 2 minutes.
Sure. Please go ahead, sir.
Yeah. Now, in this market scenario, you can see calendar-based yield prediction we can do. So the farmers they're going for the return earlier. Yes, sir. Farmers were going for crop rotation. We are now keeping the information on this demography, eligibility of this product. All this is on the portal here. So that's all. Okay, I'm having here from my presentation. Okay. Hope we have answered certain questions here.
Yeah.
So thank you.
Yes, sir. Really, it was a very great insight into the blockchain technology implementation in this agricultural field, agricultural technology in AgriTech, as well as mentoring related to the projects, as well as you have shown related to startup, that is AgriMitra. Really, it was a great insight also. You have given a different insight into the AgriTech, sir. So it's very nice of you, sir, your presentation. Please wait some of the questions. We can take it up at the later stage here. Okay.
So thank you very much, sir. Yes.
Coming to the next speaker, we have Professor Prajwal Keti. He is Assistant Professor in the Department of Electrical Engineering, Ramaya University of Applied Sciences. He has received a bachelor's degree in Electrical and Electronics Engineering and master's degree in Sensors and Control Systems Engineering. He is currently working for his doctoral degree in energy harvesting and interested in researching on diverse topics such as energy harvesting, sensor design and optimization, robotics and control systems, and application of AI to energy management. So Mr. Prajwal has published over 8 papers in Scopus Index journals and conferences. He has also filed 2 patents based on energy management in the smart home in 2017 and vibrational energy harvesting in 2020. It's very nice of you, sir, to have you here for the presentation in the AgriTech.
Yes, sir. Thank you.
So I request you to kindly give the overview related to the future of agricultural automation in India. So related to automation. Yes, sir, please.
Yes, sir. Are my slides visible, sir?
Yes, sir. Visible, and also you are clearly audible, sir. Please proceed.
Okay. Good evening to everyone. So I thank IEEE Bangalore for giving me an opportunity to showcase my topic of today, future of agricultural automation in India. So first of all, I would be telling you it will be a overview of whatever the other two speakers have told in a different way, because I come from an electrical engineering background. I would be talking in terms of electronics and robotics, kind of a mechanical approach also. So as Professor ILANGO sir told, it should be on design thinking mechanism. So I would be talking everything in terms of design thinking, and even I would be sticking on to the precision farming as the topic goes on. So today I would be talking about the future of agricultural automation in India. So that's the topic for the day. So these are my presentation outline. So basically, I would be giving you a brief overview on what is the AgriTech, what do we mean by agricultural technology, how do we actually implement robotics in agriculture, and we are talking those terms in a very brief way. Then, as already explained by other speakers, I would be just briefing you on what is the need for automation in agriculture. We have seen automation in industries, and we have some what you call the pros and cons in automation in industries. How does it help in agricultural automation also? Then we go with this, what are the available robots in agricultural technology? Are there any such type of robots? Is it being used in India? Not only in India, at least in developing countries like in India. Nonetheless, everyone knows that there are many type of robots that are available in developed countries. But then how are these robots exactly there in Indian context or in the developing countries context as well? Then our Ramaya University of Applied Sciences, we had taken up a case study with one of the private firms. So to develop an AgriBot, we named this robot as an AgriBot. I would be talking about our experience with that case study as well. And then last, I would be sticking on to the challenges and opportunities and even the future scopes of Agri-Tech. So again, as I told you at the beginning, future scopes of Agri-Tech, I would be talking in terms of the developing countries like India. I'm not going in detail like already developed countries where they have enough of resources, enough of money, all those things. So I would be sticking on to the future scope of Agri-Tech in developing countries like India. So you see with these two slides at the bottom, first I will be going through this picture. So you see that this is again a prediction. It might go wrong or it might come early also. Uh, in 2022, India is expected to cross the population of China. I don't know if the census is done today. Maybe it has already been crossed or not. I don't know. So you could see that there is an increase in the population of India compared to the China, because China has this population growth policies and all, whereas India is not. I mean, India is having, but still it's not as implemented as good as in the other countries. Okay, so why I'm talking about this population? This is one type, one part of the story. The other part of the story is you can see this was a census that was done in the year 2015-16 by the Indira Gandhi Institute of Development Research. So you could see that in 1976 or 77, average farm size, that is, we are talking in terms of a family, it's like India had around 2 hectares of land, that is agricultural land they had. But when we came to 1995, it shrank to 1.41, and in 2015, it has been shrinking to 1.08. So these two are the contrast in the story. That means, in one level, agricultural lands are decreasing, and in the other coin of the story, or in the other side of the coin, the population is increasing very drastically. That means India is now not able to India is now not able to supply its food to all the people or for all the population in the future. So that's why we require some new technologies in agriculture with a very small land. How can we grow everything? And that's the way of why the how automation is required. So you could also see that the agricultural lands, as I told you in the previous cases, is shrinking. So that means if the agricultural land is being shrinking, that means it should give rise to um, uh, new lands or the new buildings where it is actually commercially viable or things like that. So you see that there are these cities which are developed. Some farmers give lands to industries and for so many reasons. So then you can actually grow plants even in the commercial way. It can be in a very small way. This is called as backyard farming, or it is also called as the small scale backyard farming. It could be for research purposes also, right? It could be for research purposes also. So all these points you could use your automation as well. And the next question is, why do we actually require to have automation in agriculture? First thing is, you need to help farmers to combat their problems of finding labor. So you see that that's the problem of the day. Because I come from a rural background, I see that many of the farmers' son, or even the whatever the labor class people who were working before, is not in the village right now. So they have been coming to the big metro cities like Bangalore and other metro cities, and looking for small jobs. So as in now, there is a single farmer who needs to plow with his bullocks, and there are few people who just needs to plant the sapling at the starting stage. So we need to find a solution for these kind of problems, that is the labor problems. We also need to reduce the number of daily working hours and increase the flexibility with multiple functions. So this is where we are now need to concentrate upon. As in, a farmer doesn't have any time for his what we call as the work time. He needs to get up in the early morning whenever the power is there. He needs to go to the farm, switch on the motor, in case if he doesn't have auto starters and things like that, and then he needs to wait for till everything is done, and he needs to do all those things are there. So instead of that, why couldn't we help the farmers for in this technology? And also, if he could take away the time to do some other task, then that will also be a very brief way. So the other point is, why can't we automate any process like plowing, seeding, and irrigation, weeding, spraying pesticides, and harvesting? So these are all uh, the tasks which are done by the farmers day to day. Can we automate these tasks? Okay, so this is the process what we need to start to think upon. And as Professor Kulkarni sir was telling about the connected farms, why can't we know what is the water level in the canal, where is my tractor located, and what is the nutrients that are available in the soil, what is the growth of the whatever the plant or whatever the agricultural plant we have, and can we have that labor location? Is he really working upon, or is he is just whiling away his time? All those things can be done using the app or the connected world what we are talking about now. But to this to work, we need to have a good amount of internet connection available, good amount of connected automations available, good amount of sensors available. Uh, Brief knowledge on the use of mobile applications and things also should be known to every one of us. So next, coming on to the what are the types of robots that are available in the agri-tech or in the automation are some of the commonly used robots are for harvesting and picking. Some of the robots are there for harvesting and picking as well, picking up the fruits or picking up the flowers. And you can also have some of the robots for controlling the weed. So it uses image processing and other technology and takes away the weed from the farm. Then it can also be having an autonomous mowing, pruning, seeding, spraying, and thinning robots. It could be used for these type of applications also. Then phenotyping is one of the recently developed type of robots. That means, as the other speakers was mentioning regarding the corn, the color of the corn, and all those things could be done by using the automation as well. Then obviously the sorting and packing and utility platforms can also be used at the later stage of delivering the goods. So right now, harvesting and picking robots are becoming very popular among the farmers. But actually, there are other innovative ways that we could apply the automation in agriculture. I would be talking those in detail in my next slides. So again, these are the robots which are actually developed by some well-known companies. I'm not taking up the names due to many reasons, but I'm just telling you the applications of such type of robots as we are just seeing. So these are the just two of many examples that are available in the world for crop harvesting robots. These type of crop harvesting robots, which you could see here, actually picks up the flowers and the fruits in a particular farm, right? So this it uses an image processing technology. It will have an end effector. End effector in the sense it would have a mechanical setup. That mechanical setup binds to the flowers or the fruits in a very fragile way, and then it takes the it plucks the fruit or the flowers. So here you could see one more type of the harvesting technology that are used in nurseries. So when you come to nurseries, you need to maintain some gaps, which you could see here. So again, these plants will be brought from some other place, and this robot will keep the plants in a very better way, with maintaining the distance between those plants and having the sunlight or having the wind for their growth. So this is one such type of crop harvesting robots. I mean, there are many, I told you. These are just 2 or 3 types of crop harvesting robots. The next robot is, it's an important robot. This is called as the weeding robots. It helps in removing the weeds from the field. So again, here it will be having a camera. It will be having a camera, and once you program it using a PC or using a mobile phone, if you program that robot to identify the weeds in the particular land, it will tell you, it will actually pick the weed and it will destroy that weed and things like that. So next is, you have come across the spraying robots. It actually came into limelight in pretty 4 or 5 years before, but now it's not to be seen. So it sprays the pesticides using the drones, all those using all those technologies. So that this you have already seen in many of the things. And as other professors mentioned, you also have a surveillance robots. It helps in spotting diseases in crops, and even for the crop insurance activities. No need for a government official or the insurance company official to directly come onto the farm and then check and click a photo of it. He could just he could just send the drones, right? And so these type of robots you have already seen, or this is already existing. So now we are just moving on to the next type of robots, which are actually concentrating in the developing countries. We are seeing this type of leg robots. You could see that instead of having a wheel, it has a leg. So it manipulates the walking phenomenon, which is actually very necessary. So I can call this type of an robots as emerging type of robots, which are applicable in the agricultural lands. So now I'll be moving on to the case study, which was developed in Ramaya University of Applied Sciences. So this was to design and develop an agricultural robot, which was used for these 3 purposes. So sowing, watering, weeding. For these 3 purposes, we had to have. So again, as this was just a prototype, we built with a small dimension. We just wanted to prove the concept, prove the working concept using the small technology available, using the very small, very geeky technologies that are available with us, and then we proved it with the prototype building as well. So all these 3 points, that is sowing, watering, and weeding, were just possible with just the change of this end effector. You could see a funnel here, right? So this funnel was used for seeding or sowing, and then if you could we could change this end effector for watering, it was applicable, and even for weeding also it was possible. So as the Professor Prasad Kulkarni sir and the other Professor ILANGO sir was mentioning about the design approach, design thinking approach, it involves the combination of engineers. It's not only electrical; it should be mechanical. It should be computer science engineers. So this was this was the brief block diagram. We had to use a sensor for sensing the soil moisture. That means when we had to automatically water, or in what level the watering should have been done. All those things what was measured by this sensor. Then obviously you need to have a UI, or UI and user interface and user experience. You need to have an UI. So we had to develop an UI using the available Microsoft technologies available. Then we also used rotary encoders in X, Y, and Z directions to just know the how much the movement has already been done, what is the requirement, and all those things. Obviously, there were motors for the movement, and there was a solenoid valve for watering and seeding application. There were limit switches in X and Y and Z directions to limit the movement in case it should not go out of the context and all. So we used a control logic using a microcontroller, which was STM32F. We used this again. It was just by using a C and C++ logic. We had done it using using the same technology. Now, this was the UI what we had developed. GUI was developed to control the AgriBot position network. So if you need seeder, you could select this. Then if you need to test the soil moisture, you could select this, and whatever if you want to water it, or if you make it as an automatic. So here it has made an automatic way. That's why the functions have been blurred. And obviously you could also save the number of seeding points. That means first actually you need to declare the spacing. That is what is your farm size. This is the plot area. So you need to declare what is your farm size in X in inches and Y in inches. Then what is the spacing that is required for you with each X and Y coordinates, right? All these things you need to declare. And then if you could start the robot, it could start by itself, and it could be controlled using a PC or mobile phone using the Bluetooth technology. So this was the path that we followed. As an example, we took a plot area of the 12 by 21 inches. We also had to have the spacing of 2 inches and 4 inches in X and Y directions. So this was the plot area. That means this was the path that was followed by the robot. So this was the point for the reset homing position. This was the point where the robot would start at the beginning, and then it would move to this particular place, and then it would seed at this particular place, which is called as 0, 0, and then it would go on. So these points are actually obtained by the interpolation algorithm, a simplest algorithm. If any technical guys are watching this, you know this. This is the simplest form of the algorithm which you could use for the plotting purposes also. So now I have talked about the electronics and the electrical and the computer science way of programming and all those things. But yes, how do we develop a robot, right? The robot arm or the robot external features that you need to be developed by a design engineer, or you need to contact a mechanical engineers as well. So first we decided among the concepts what could be the concept design which we could have for our AgriBot. So first we designed this 5-motor robot. This was our concept one. It had 5 robots, 1, 2, 3, 4, and 5. It was pretty easy to balance for this, but actually the cost was more. As you could see that there are 5 robots, the cost was more. Then one more concept we developed. So we reduced the number of motors to 3. But the main challenge with this particular setup was the balancing was really tricky. So used 3 because of controller output limitation also, whereas the STM microcontroller what we had was the output pin limitation was there. But yes, even though the balance is tricky, it seems to be a pretty best option for us to do. But in order to balance those, as I told you that the balancing was tricky enough, we introduced these blocks which you could see in the blue color just to balance. That is adding a counterweight, what we call it as. So this was a design stage, and then we actually had the CAD modeling done. We also had a stress analysis, and we also had a fatigue analysis done for this CAD model, and then we actually developed this particular case study. So, again, next coming on to the seeder, that we just use a mere funnel. Has a hopper or the funnel-like structure to feed the seeds, which has a small hole. So the solenoid could just open up and it close down, and it could actually sense how many number of seeds uh, should have been planted. So sometimes it just requires one, and sometimes it requires more than one. So that is controlled by the controller output, which we use a solenoid here. It actually says it actually you can think of like opening and closing this particular gate. So that was regarding my experience, our experience at Ramaya University for developing the AgriBot or the agricultural robot for those 3 applications mentioned as well. So taking to the next part of the session is the challenges and opportunities. What the agricultural technology that are being implemented from long ago, what are the challenges and opportunities that any person, not only an electrical engineer, not only a computer science, not only mechanical, as a whole, how can we answer to the questions which are raised by our honorable PM for the digital India and for the betterment of agriculture and mankind? What are the challenges and opportunities? Yes, if there is a challenge, you need to take up that as an opportunity, and then you should do it. So the major problem in India is the interoperability of farms. Interoperability of farms is nothing but So in one particular year, we actually sow one type of crops, and in the next year we actually change it. So obviously, when a farmer thinks about buying a robot for himself, he needs to use it in everyday basis, right? So if he is not using it on everyday basis, and if the interoperability of farms is there, then obviously he may actually doesn't want to buy it. Then learning curve of the farmers. Again, it's as sir already told, they they use the technology for the betterment. They use just the Android and Siri, Alexa, and all those things just to open YouTube. And obviously, farmers are now becoming coming into limelight, and their learning curve is increased. But majority of the farmers who are illiterates, I don't call it them as illiterates, but they are but education is very less. Maybe they cannot actually they find challenges in using the mobile phone technology as well. So the next point is, as we know, everyone, the connectivity in the rural areas is really poor. So if you see that 5 or 6 years before, no one had 2G connectivity also, but now yes, there's a with the liberalized spectrum and with all those points coming in, everyone is trying to concentrate for 4G and other technologies. And yes, the connectivity is being increased as well. So lack of scalability and configuration problems. This is one of the major problems. You cannot scale your technology very much easily to a higher level. With these kind of robots, you need to have a technically skilled people so that it could be scaled to the next level. So also the energy depletion risk. Some of the farmers are thinking that if you use too many robots or too many such devices, your electricity bill goes up and all those things. So again, these are all myths. You need to you need to throw away all these myths and start using these technologies. So again, there is a challenge for indoor farming also. If you don't have enough of light and enough of all those parameters, your algorithm might not work. People from image processing background could actually understand this problem. So obviously there are technical failures and resultant damages. A security factor, obviously. So if you are implementing some sensor in a remote field, you might not know that the sensor is safe there. So farmers think that some other person will come and take away, and he may sell that off also. So that's the security factor, which is really a challenge in India to implement these automation risks. Benefits not immediately apparent as I don't say it as actually a challenge, but now farmers are understanding the benefits, and they are actually learning. So again, this is a challengeable point, that is loss of manual employment. I don't want to go in much detail because that would be a debate debate as well. So in Indian agricultural realities, it's actually there. Then sustainability issues you have, and technology as an enabler. You need to enable the technology in a remote places also. So these are the automations that are actually existing. You have seen this automation as well. So in India, there are two major crops are nothing but paddy and wheat. Obviously, the automation for paddy, right from the cropping stage or the harvest, from the seeding stage to the harvesting stage is ready. Even for the wheat also is been everyone knows about it. But the next challenge of the opportunity is because I come from the Malnad side of Karnataka as well, and we have these crops. Again, this is just as an open challenge to every one of us who are working on this robotic technology. Can we? Yes, there are few researchers, or there are few prototypes which are actually concentrating on how do we take up this areca net. So these are nothing but the areca net trees. How do we actually take out this areca net using a technology? So the major challenge is this tree, the crop from each and every tree is very small. So what happens is, manually a person climbs only one tree. He removes it, that particular crop, and then he does not climb down. He actually travels from one tree to another, and he does like that. So implementing automation in this way is really a challenge. So we are actually concentrating on this particular area. And also the second most available crop in Karnataka is banana. So you cannot again, automation here also is really challenging. I don't say it's impossible, but it's really challenging. Um, So coming on to the future scope of AgriTech, how do we actually, what is our future? Is nothing but most Indian agriculture is not as rich as Western, because I come from an agricultural background. We know the realities. We are not as much as rich as the Western farmers are. Uh, Technical knowledge among the Indian farmers is comparatively low. Again, it's a challenging question, or it's a challenging point. I'm just telling it's comparatively low. So hence challenging to implement automation in agriculture for complete India. But yes, if you could answer to these points, obviously you could implement to the complete India as well. Then cost of buying the automated farm equipment is huge. Many farmers cannot afford. So answer for this question was already given by the other speakers. That is farming as a service so fast. So you could actually use a service or kind of an approach, and you could do it. So poor connectivity issues in rural India. So that's the background of agriculture. So can we address all this, but yet develop a sustainable solution is what the solutions what we want to prefer. So what is the future? What is the type of automation that you require from now on? Is nothing but you need to predict the weather and monitoring this system. Yes, there are many such systems are existing, but as a standalone systems, it has been existing with a private entities and GOI. Could you is it possible to integrate these systems as well for the well-being of the community? Are the companies ready to give up their technology as an open source challenge? Can we introduce big data analytics and AI for this weather prediction and monitoring system? So the next point is, can we monitor the crop? So crop disease is a major concern for farmers. Some of them doesn't have much knowledge on the crop disease, and this is actually affecting their 20% of the revenue. So could we use image processing to detect such diseases? Are systems available to be shared or open source using a common platform as well? So you have these driverless tractors which were developed by M&M, that's Mahindra and Mahindra, showcased in such systems in September 2019. But after that, it did not come into limelight for many reasons as well. The next thing is you could see the lands in the, at least in Karnataka, where we grow rice or the paddy, is multi-terrain. Multi-terrain is nothing but it doesn't have one level, it will have many such levels. So using robots in this kind of approach is really difficult. So robots should be able to work themselves with such challenging terrains. That's the reason why I told you select robots. So again, this is the major thing for specific problem statement for South India. So after the areca nut harvesting, what they do is this is the areca nut shell. So this is actual picture which was taken, and they would actually put these areca nut shell into this machine, and it will chop off the areca nut shell into these areca nuts. But the challenge here is it doesn't know how much to chop off, and there are some times the areca nut itself will be chopped away. So again, a technology is required in this particular area using an image processing and such type of things that we need to do. And obviously, once you get this areca nut, how do we boil it? What is the particular temperature that they require? They actually see the color, and then they will say, okay, this is the color what we need to boil it, and all those things. So could we implement this areca nut harvesting robot, or can we make this areca nut as a particular research topic? So that's where we have, and obviously coffee and tea is yes, this is, I don't think so any automation is done in this particular field, at least with small knowledge what I have, because it's a multi-terrain and unconnected is nothing but even the connectivity issues as well as we have. And obviously it's a labor specific intensive work. There are challenges that manual employment might be lost, and yes, we don't have such things developed. So at the conclusion, what I want to tell at the last is, yes, smart farming is available or it can be implemented, but with the sustained efforts by both the center, state, and even the private sectors. Obviously, then the rural connectivity issues needs to be done. Obviously, more research needs to be concentrated, and rules have to be liberalized for startups working with AgriTech. Obviously, 2 or 3 days before, I read that the drone technology rules have been liberalized. So that's a big thanks for them. Then a training camp should be arranged for the farmers and other users as well. Yes, India will remain in the race of AgriTech with a huge investments from developed countries as well and the entities, and mainly with the sustained efforts of GOI. Thank you, sir. Thank you for giving me an opportunity.
Yes, sir. Really, that was a great insight that related to AgriBot, what you have developed in your university, as well as what are the challenges you are clearly explained. And many of the questions which were posed during the registration time, you have covered all the three speakers. It was a really a nice overview of the AgriTech. In view of the time, so let us take up only some of the questions so that we can complete by 8:15. I request all the speakers to come on video so that we can have a discussion. You can switch on your camera, please. Yeah. One question like compiled together. Let me put it together. So if we go back to the ground reality. What is the response of the farmer at the ground level? This is one question. And related to that, farmer education and awareness is equally important for automation to be successful. Parallel programs, initiation to train farmers can also give an insight into it. This is one. And related to that, one of the professors have asked, I want to introduce AgriTech as a subject. So in the curriculum, can you kindly, each one of you, can you give your insights into this? We can start with Professor ILANGO, sir. You can take up any of the questions, sir. Should I split it up? No, you are mute, sir. You are on mute. Kindly unmute yourself, sir.
Yes. Can you hear me?
Yeah, please.
Thanks for asking question, very intellectual question. I appreciate this courageousness to introduce the AgriTech subject in this situation. Really, congratulations. We have to appreciate them. That institution, I do not know which institute, which state that. There's a plenty of opportunities there. As we discussed the last 2 hours, AgriTech, it's not only one technology, it's integrated technology. So without computing science, we cannot go for complete the technologies effectively, electronics, electrical. So my suggestion would be when you wanted to keep a subject or course, either short-term course or long-term course. Short-term course, maybe 3 months to 6 months, you have to plan properly. If you have 3 months to 6 months, you can have a very basic component related to agriculture. If it is intermediates, 1 year diploma, 2 year diploma, you have to think about a specific subject. If it is a PG diploma or graduation, you have to keep a very specialized subject, integrated subject. So it is a lot of homework to be done. But as of now, I would suggest that you can refer Indian Council for Agricultural, this is ICAR. They have exclusive research domain on this. They are hosting a lot of training. You can take their support to get that syllabus formation. I suggest that you can keep technology like blockchain technology in agriculture, very predominant things is going to play major role in India. And drone, it may be a separate subject. Drone application can be a separate subject. It's not so easy to frame it. You need to consult the expert of drone. Legal issues will be there. You can learn theoretically, but the implementations, again, you have to get licenses. One problem is there, but you have to keep, it's a good, interesting. You get market value if you keep this subject. One subject can be drawn exclusively as a short-term course or 3 months course or 40 credit course, sorry, 3 credit course or 40 hours course like that. Blockchain is a exclusive thing, and big data as well as data analytics, AI based thing. You can keep on exclusive domain and crop manufacturing. Sorry, management system. You can keep on thing irrigation management like that. You can subdomain. You can fix it. In Bangalore, we have agricultural universities there. You can take their support. In India, there are so in Hyderabad they are doing super managed. There is a big institution, as I was showing in my presentation. They're offering excellent course. You can go to their website, you can download the curriculum, you are able to get it. So this is my suggestion. You have to make a framework fast. Just like that, you cannot go to that stakeholder or students or management. It's a agri-tech subject. So you have to define the goal, define the objectives, define the framework as per the statutory bodies which is there in India, like ACT as well as UGC, maybe state board, technological universities. You have to talk to them. But whichever I said, the subject is a very important subject beyond that. So you can have DNA also, biotechnology subject is very important because crop, we have to have amalgamations and produce a new type of crops and all. So any support you need, you can always approach IEEE Bangalore section. So they will connect with us. So we can have BOS meeting if it is required. We can help you to formulate a subject in a remote area. We can have exclusive session for that with your management, with your support IEEE Bangalore section. You can join, you can take ITD Bangalore section is your partner, technical partner to host this course. So some of our expert can host online mode as a course to help you to launch this course. This would be my suggestions for that questions.
Sir Kulkarni sir, any insights and
So I'll try to answer a few questions asked directly to me. One
yeah,
is, yes, there is a crop planning Mitra. Exactly what is the crop life, and when the pest will come, what is the weather, what is the market condition. So that we are doing it. Second one is awareness. We started working on visualization. When we started with the application, mobile application, we made it a lesser number of keyboards, and people can put one or two and started with the crop API, then went to the market, then went to the crop planning. So if you go by face, farmers will not having any problem. And the regional content is driving our sales here in the. So you have to enable the regional content. There is a not Microsoft HoloContent technology is available. Google Translate technology is available. You can translate it voice and text to any language today. So that is not a problem. So if your background is good, so educating the farmers is not an issue. These two questions were asked to me directly. I have answered. Yes, the government is this demonetization when we were developing crop API. People asking, can so bringing the Bitcoins to the blockchain and to be approved by the RBI in India. So it is done outside the value, so we have not experimented that. So, but that is a risk here. Second one is financial institution. If the government records are public domain, if someone posts the public algorithm and tags it and modifies the hash from the government side, as a third party, that's a risk that is there. So financial institutions are little scary about this hacking side also. So therefore, they are reluctant to come into the blockchain.
yes. And can you give some insights into what is the ground reality, like how the farmers are accepting and related to the economic condition, how can we bring with these technologies, how we can bring it up so that definitely the GDP is going to grow with, which is very, very helpful for our farmers also. If we can throw some points on this, some insights. Yes, sir. Anybody? Professor Prajwal, sir? You want to?
Yes, sir. Coming to the economic aspects, I know it's very, at least our farmers are not as rich as the Western farmers or the other developed countries. I think government should bring up the subsidy model and even the farming equipment as a service model. So that I think that would be the better approach, and even the cost-effective robots could also be designed with a new material science engineering materials to be done, and even the whatever the sensors which they could use, or even the controllers what they use, in order to bring the cost down, they actually can use these sensors from which they as a secondary equipment. Secondary equipment, what I mean is, in case if there is some electronic equipment which is not being used, so they can take up that and re-engineer that, and they could actually use that. So that's my opinion on how do we bring down the cost. So,
Yes, sir. Professor ILANGO, do you want to give some input, sir, related to this? The ground reality.
Yeah. It is actually every new innovation or new idea when introduced to the market or society, there will be agitation, there will be a dissatisfaction. But only way we have to educate farmers. So when we used tractors in 90s and 80s for agriculture, there was a big agitation. Now in India, it's the highest manufacturer tractor manufacturing country in the world. They're exporting, they're using that, they're accepting that. So it took some time. So like that, this scheme, a lot of innovative scheme government has introduced. Any government come to in India power, they are always focus agriculture very effectively, efficiently. We have to educate the farmer from primary health center is there for health, like that we have panchayat is there. From that area we have to educate the leaders. The leader will take into that their subordinates. So educate the scheme, utilization, loan facility, subsidiaries, what is there, gram panchayat, like that. So many things is there. From that level we need to educate. Even when we introduce a mobile phone, farmer was hesitating to use it. Now many of the farmer, they are in the field, they are using mobile phone effectively very efficiently. They are known how to operate the phone. So that because of education, either self-learning mechanism or somebody trained them. So it is possible, but the team should form ecosystem to be created, effective ecosystem, either as a mission activity. There should be a driving force, some leader take a initiative, form the volunteers, and from the volunteers can go to as a NGOs or as a CSR scheme, they can educate weekly basis as we are doing IEEE chapter monthly lecture. Like that, if you take into rural area, we can attract them. Best way to do regional languages, not in common language. It reach quickly and efficiently, effectively. You could see Bangalore chapter think there is a possibility for Bangalore chapter in India. There is a scopes are high. They can take into all the regional languages in India, can connect it. Then within 6 to 8 months, there can be a transformation about this. The fear will go out. So government always is there to support.
Yeah.
Officers
So
are
one
always there to
more
support.
brief from my side. ITC, when they introduced e-Chaupan for the soya seeds, they introduced in the Hindi language. Today, farmers who are trading in the Chicago Board of Trade, and many MBAs and investors do not trade in commodity, but farmers in down district, they trade in commodity exchanges in in the CBD. That shows that farmers given little inputs in their regional content, visualize it, they will accept it. So therefore, that should not be a blockage in the future. And most of them are going to the literate by the next 10 years. So, okay, illiteracy is not an issue in the rural area because I come from the rural area.
So we
Yeah,
have to
Just to
become
add on
mentor.
for that point, I think even the government of India have understood that the technical education should be in the regional language as well. So I think recently government has approved the regional language engineering technical courses also. So I think what Professor ILANGO sir told was well with the point. Not only the agricultural technology, everything could be in regional languages as well, so that the agitation could be reduced or even nullified also.
We
Yes,
have to
sir.
become mentor, volunteer mentors. So we
Volunteer
have to
mentors.
create mentors and we have to become mentors. So we have
Yeah.
to take to the society. So
Correct.
that is a possibility.
Yeah.
That's why it is possible in India. There is a scope.
Yeah. And one more question was asked related to the reality. Why automated solar water powered pumping is still lagging? Are there any problems related to that? Automated solar water powered pumping.
So actually,
A company I need to explain. In Belgaum district, there was a company called Grandfuss. They use the solar powered motors to lift the water. Service, backend service was not there. There was nothing wrong with the technology. They do not have a service backup. And the solar energy is abundant in this area of North Karnataka. So you don't have when the repair service, there was nothing. And the cost of installation is still high in the PV solar cells. But China import is coming, that is coming down. And even local manufacturing is scaling up. So that will come down. But the local service has to be given. If this point is not taken, then solar water pumps will not be successful in India.
Yes, sir. I request any of the attendees, if you want to ask any questions, kindly unmute yourself or please raise your hands so that we can have another 1 or 2 questions and we can close the session, sir.
Hello.
Yeah.
Hello, my name is Manoj. I have one question which I have put up in chat box also.
Yeah.
I want to know any companies or startups in India are working on developing the phenological network like how we have in the European or Western countries. Crop phenological network. Any companies or startups are working on that?
Sir, I told about our crop planning process in the AgriMitra. You were talking about growth, then diseases,
Yes,
the death,
yes.
everything in the entire cycle. We have done it for rice crop in Belgaum district. So we are exactly finding it out when you should sow the seeds and when you should put the insecticides or pesticides.
Yes.
Then, sir.
Yes, yes, I am listening, sir.
Yeah. So when we tell you when the weather will change, what you should do, we also tell what is the market when you should harvest it. So this entire crop planning is predicted and told 2 days before to the farmers.
Okay.
Yes.
Thank you.
Any other questions? So this is an opportunity to interact with the experts. Kindly, if you have any questions, either raise your hands or you can just unmute yourself and ask the questions.
Hello, sir. It was a great session. Like, it was very informative and all. So my question is like, how can data science bring an impact, like bring a change in agricultural sector, like agriculture field as a whole?
Tell you one
Well,
simple. Yeah. The precision agriculture that we are talking today, we are taking a lot of images. We are doing image analysis. I told we have taken two areas of the field and said which area is giving higher yield, which area is giving lower yield. And data is taken. And we made it is less yield in a one particular area. Then we went to the nutrition level of the soil and the weather condition, water level, everything. Then we suggest the farmers if this should not be their case and what nutrient it is lacking. So that is how we do image analysis using artificial intelligence. Okay, remote sensing is coming out, the sensor technologies are coming out, LIDAR technology is coming out in agriculture today. So these are used as a data analysis backup. Data is generated, analyzed, and the input is given to the farmers.
Any other questions? So it's already 8:18.
Yeah, good evening, sir. Once again, sir. So this is Kamar Kumar, sir. So I'm from Triple Department, that is Electrical Engineering. And excellent presentation by the three speakers today, sir. Thank you very much for providing these updates here. Sir, my small doubt is, during my research, my PhD in this agriculture, by providing the continuous power supply. Okay, so as of my literature, I have studied so many papers regarding that how to sustain the agriculture. The government of India, they are providing a lot of schemes, the farmers and end users. So why that agriculture still is lagging? Already you have explained in the session, but as a part of electrical engineer, so why to sustain that agriculture is the right choice to me to select as my PhD or my researcher. Please give me this suggestion. This is the okay for as of now.
They were talking about agriculture sustainability. That's a very good topic that you were selecting. What I suggest is, use the real-time analytics. That is where it's coming up. So that will back up as a machine learning model for you in the PhD. So data is there in farmers.gov for many things today. And also you can get more information about clean energy and clean technologies in the agriculture. That is the area which is coming up. Water technology is a big one. That is called as next industrial revolution in the agriculture. Society 6.0 they're talking about. So that is, your project will definitely help there.
Thank you.
Yeah. Any last one question? Anybody, if you want?
Sir, like I would want a perspective from all panelists, like how can we involve youth in this agriculture field, like just in like not in research thing, like the occupation of the farmer is like decreasing day to day and population is decreasing, like as sir told. So like what would be the measures, or like what would be the what approach from the government,
Yeah.
also like you
I understood.
Yes, sir.
So now, as we know, as work from home has started, and especially for IT firms, I think it would be the future down the lane. Might be hybrid work mode also. So when you come for hybrid work mode, it's only like 1 or 2 days you come to a company and then again you move back to your hometown. So what I suggest in that cases is take up agriculture as a part-time work. Don't consider it as a job. You can take up as a hobby. Try to implement whatever you learn in your technology. If you are a computer science guy, whatever the algorithm you have, could you take up one small sensor from any cheap website? You try to program that sensor and use it, and try to algorithm wise you try to program it, and then try to use that technology. Is it working fine? Then you move on to the next step. So what I suggest the youths is take up as a small projects and then make that as a big prototype, and then as the other professor suggested, you could actually gain a patent also in case if your innovation is very high, right?
And also, you can attend the hackathons. There are
Yeah.
various hackathons organized globally. Now it is a good opportunity, virtual mode. You need not to go. It is start from 8 hours, 12 hours, 24 hours, 48 hours, 72 hours. Even Government of India, very good hackathon they are organizing every year, Startup India, they are starting, and agricultural grand challenge. They are giving lakhs of rupees in that. They are giving excellent thing. They are organizing. You go to ACT website, India, you could get that a lot of hackathon, and Government of India, Ministry of Human Resource, they are purposefully organizing for education institution. You can form the team member, 3 or 4 students, as Prajwal said, that you can have the mini projects that you can project it in the hackathon also, online also. There are many companies observing this kind of group, hackathon hackers. They are sponsoring for your ideas, as well as you are getting job opportunity. Even though you don't get job opportunity, it's fine, but you can do the startup, or it will be a good learning for you, your future purpose also. Offline resume, it will be good, but continuous learning with your team, attending hackathon with the senior professors, some mentor helps. Now not only the Government of India, the website, they're loading learning material also. Even NPTEL is there, SLAM is there. You can download a lot of materials to learn. Attend this hackathon, you will get a lot of transformations. That would be my suggestions to the member.
Yes, really, it was a great insight from all the 3 experts from agricultural perspective, as well as the technologies in agriculture. I request each of the professors, starting from Professor Prajwal and then Professor Kulkarni, to give the last word for the today's presentation, today's session, sir.
Sir, first of all, I thank IEEE for giving us such an opportunity and arranging a webinar series regarding AgriTech. So nowadays, agricultural technology is coming into limelight. So I think everyone needs to concentrate on agricultural technology, not being any, me personally not being just an electrical engineer. I'm concentrating on all the domains. Like that, everyone have to concentrate on all the domains to make the successful implementation of agricultural technology and agricultural 4.0 and 5.0, as the other professors term. So I think every one of us, if we are concentrating on this sustained development, engineering development, and I think we could fulfill our farmers' needs on day-to-day basis using the sustainable technologies and with the smaller energy as well. Thank you.
Yes, sir. That was a nice
Sir,
insight.
once again, thank you for giving me this opportunity. Yes, we speak in front of the dignitaries here. There is a big role education institutions is having, particularly faculty coming from the rural area, has to encourage the engineers to take up agricultural innovation and technology, because even today, our 16% of the GDP depends on the agriculture. So we cannot ignore this, and therefore a lot of innovation has to come. And we're talking about Industry 5.0 already. Cognitive computing, quantum computing is coming out, nano materials are coming out. So cost should not be an issue. Research is the issue. I request whoever in the fraternity, please come and do some research on the agriculture, which is. Thank you.
Professor?
Yeah. Thanks for given us opportunity to deliver our ideas to the big forum, Bangalore chapter, and Professor Raghavendra and other senior members in the forum. My suggestions would be anybody can learn AgriTech. There is no need of formal educations, qualifications to learn, because it is our DNA. Agriculture is our DNA. India is known for agriculture for many centuries. So anybody can go. But the only thing, mindset is very important. We should have a positive mindset. We have to go to the field. We have to meet farmers to learn. For example, many are willing to go for plain land only. Why not you go for a hill area? There are people suffering. If you go to Seven Sisters in India, there is a Northeast, there is a small state, they are suffering a lot. They need a lot of solutions for their agriculture, but there is a good resources are there in that, but it has not been customized, it's not been commercialized. We can extract more. You go back to Northwest in Kashmir and other thing, there is a fear factor. We go that what will be happening. There is also costliest things like badam and nuts and apple like that. It's happening, growing the commercialization. Why they go export just like that? Why not utilize that? So we have to visit, we have to provide solutions like terrestrial wise. Not only that, we need to become a volunteer. I would suggest that create ecosystem in your institution, in your organization. Why suddenly the AgriTech came into market? Because somebody thought to develop a solution, IT based solutions to the farmer. Then everybody followed it. Like TCS, they crossed various struggle, followed by Wipro and Infosys, followed by that Cognizant. Now many of the IT company came followed by these groups. Like that, someone take lead, AgriTech lead. We can follow. We can create ecosystem in our institution itself. Nurture the students, nurture the professors, faculties, and our relatives. Even our own home, we can nurture the people. What is our difference for organic product and non-organic product? What is the differences? We can ask them to study, so we can classify it. We can observe it. We can go and purchase if it is possible, free time in the weekdays, direct to the field, ask the problem of the farmer. So this would be my suggestion. Nurture from the school, talk to the children at home, then school to higher education, then formally research come. India certainly from right from now in 10 years, India will be number one countries for agri-tech in the world. There is a scope already. India started a super startup in the world countries. They are going to reach within 5 years in USA or China, Israel. These are the countries that are dominating in the world agri-tech. India is in the fourth place. When it is a fourth place, how long will reach to take second place or first place? There is a IT. Here we have capital is there, intellectual capital. All possible. Nurture from home, from school, from children, society, state, and education institution. There is a possibility to get the transformation. Thanks for given opportunity, Professor Raghavendra sir. IEEE chapter is always there to support people to help and grow. Thanks,
Yeah. Really, it was a very nice session from each of the speakers. You have given the great insight into the agri-tech in the field we have worked and also the expertise. Definitely, it's a really a great thing. I have shared the link for the feedback. Kindly fill up the details so that we can come to know what are your expectations in the future. And in the coming week, in the coming month, on the 14th of August, that is on Saturday, we have future networks. Again, 3 more speakers will be discussing. And on 18th September, we have got transport electrification. And on 16th October, space tech. And even if any of the faculty members or industry persons are interested to give the presentations, really it's a you can share the knowledge with our students as well as professors and experts so that we can take up in a very good way, and the knowledge sharing plays a very, very important role. And coming to the video sessions, so the video has been recorded, and in a week's time, it will be uploaded into IEEE Bangalore section YouTube channel. Kindly wait for it. And if the speakers would like to share their PPT, they are asking if you are kind enough, then you can please send it to me so that I can further send it across to the participants if you are okay with that.
Yes, sir. I am okay with it. I think I've already done it.
Yeah, and 1 or 2 announcements I will make, and so that in a 1 or 2 minutes we are able to complete. So there are many projects were also shown. So we have already announced the IEEE Region 10 Humanitarian Technology Conference. It is related to R10, so that is the South Asian countries. All these it's participating. Students as well as faculty members, you can observe if the farmers are using any of the projects which they have made it on their own and they are using for the purpose. So we wanted to bring it to the stage so that this can be done, and also it will be useful. For that purpose, again, we have announced the project demonstration and presentation. you have to make a video of that, a 3 minutes of video, and also find out what is the cost of it, how they have manufactured, and what is the purpose, and what they are utilizing. So definitely they can take part in such presentations of these projects. It is really rewarding, as well as the students need not have to work on the project. They have to identify what is already being used by either the farmers or anybody for the local purpose they have developed on their own also. This is a good initiative taken by IEEE Bangalore section, as well as we have got IEEE Region 10 conference. Kindly participate in this, so that AgriTech related to agriculture also, there are papers have been asked, and really it's a great thing to participate in this here. Okay, I request all the participants, and also so to please switch on the camera so that we can have a photo for the remembrance of this. Kindly switch on your camera for a while.
Sir, can you share the link? Like we recently you told about the compilation.
Sure. For all the, so kindly fill up the details about the fill up the feedback, so that you can mention your email ID also. We are going to share all the details so that I'm going to send it to you, sir. Or otherwise, IEEE Bangalore section, if you can look into that, definitely we are going to you can have it like that. So 1 second, please. Kindly hold on. Yeah, that's a good thing. So last 1, 2, 3. Yeah, I have taken the photo. So it was really a great session, and I really appreciate the interest taken by all the 3 professors in sharing their knowledge, and also they have voluntarily given their time, as well as the technology they have shared, and what they have worked out. And you have given a great insight into this AgriTech, so that people can take up the research, as well as the students can also work out. And nowadays, the students are taking up the agriculture technology, and also they are grouping together in different not only from computer science, electronics, and the other departments coming together, and from the perspective of design thinking, they are thinking in a very great way. That is the Generation Z. They are looking into the future. So what they can do, definitely they can help it. And such type of presentations by the professors and also the experts, it is going to give a great insight. I thank the professors, Dr. V. ILANGO, Professor, Head Center of Excellence, for giving his great insight into AgriTech, sir. Kindly accept our memento. I request Rutvik, a virtual memento we are presenting, although you have shared your knowledge. Since we are far away, and again we are coming up through this, Rutvik, is he available? Yeah. Thank you very much, sir. It was really a great insight, and you have given a nice to have you. And we had Prasad, Dr. Prasad KULKARNI. He is a mentor, agriculture startup. You have AgriMitra. Really, you have brought up so many things related to AgriMitra also. So many things. It's really a great insight. I thank from IEEE Bangalore section. It was really great to have you as a. Thank you, sir. And Professor Prajwal, he has demonstrated also, and what research work he has done, and also you have given a great insight into what are the challenges which are faced by implementation of AgriTech. Really, you have given a great insight, sir. I thank you very much for giving your lecture, as well as sharing your knowledge. Really, it was a nice session. The participants who are really interested to participate, and also to give and share their knowledge, definitely we are very much interested. And also I thank completed and the chair IEEE Bangalore section, Dr. Bindu Madhava, for providing such opportunities for the people to share their knowledge and also expertise, so that we can focus upon how to bring up, how to solve the problems which are faced by India, as well as in the technology also. Really, it was a great insight. And also for the directions from our Prashant Mishra sir, who is leading this, so that he has given an opportunity how to go about, so that we can bring people together and also have a great discussion. Really, I thank from the bottom of my heart all the participants, so that you have participated, although it has taken 2.5 hours time, since it's a very big subject to be discussed. Almost, I think the great knowledge our speakers have, I think we can definitely we can have a 3 days workshop also, or maybe a one week workshop also. Really, it was a very great insight all the speakers have given. I thank all the speakers who have voluntarily come across and also have shared the knowledge, as well as all the participants, all the IEEE Bangalore section members and also Exicom members, and also the participants, students, and also the questions were also very good, so that it is going to give so many other insights and what the stages we can take up, so that we are coming up with the great educational series from the India also, so that how we can address the future of India. Really, it was a great session. Thank you very much.
Hello.
Yeah, please.
So
Yes.
just before we end, on behalf of IEEE Bangalore section, I would like to thank you for being an amazing host for the day and moderating the session really well. I think the session has gone really amazing, and kudos to the team from this professional activity team.
Thank you very much. Have a great weekend. Thank you one and all. Good night, sir. We are leaving from you. Thank you.
Thank you very much, sir. Thank you, sir.
Thank you. Thank you.